discussion. And the great deceiver, the thing about flat Earth that really blew my mind was when you discover the Rayleigh criterion, and you see that the Rayleigh criterion is that the calculation is 1.22 times the square of the diameter of the lens. Will tell you at what point two lights will merge into one. And then when you look into flat Earth, it's 1.22 times the square of the height of the observer. And that'll tell you when objects start to disappear behind the horizon. And this is what's so incredible about the nature of the great deceiver, is that he took the spherical nature of your eyeball and how your eyeball bends light, and how that then gets projected onto this flat plane that makes it appear spherical, or like there's curvature. And what you guys are talking about the lie, how long can you keep a lie? If I show you a white swan and I tell you it's black, and everyone believes it's black because we've told them it's black, but it's actually white, you can't keep that lie very long. But something like this, where the eyeball is the thing that's actually distorting what you're seeing in your reality, means that most people will see a vanishing point. Most people will see what they perceive to be a horizon. And because of a vanishing point and a horizon, which is based on 1.22 times the square of the height of the observer, or 1.22 times the diameter of the lens through which you're looking through, that you can determine where that point will be, shows that it's optical, that there's something to do with the human eye, the shape, nature, size of the human eye, that allows the mathematics of a spherical model to remain hidden, even though it's obviously and demonstrably and provably not a sphere, that there is no underside of a ball that people are clinging onto. But through optics, it remains just in the realm of invisible. So this isn't an obvious lie like the white swan is black and everyone must just agree that it's black. This is how great Satan was with his deception, in that he used the spherical nature of the eyeball over this flat plane to work out all the mathematics to make everyone believe it's a sphere, simply based on observations through an eyeball. And then when you look into the globe Earth mathematics, at 10,000 feet, you're supposed to have 666 feet of drop. And when you look at the speed of the Earth around the sun, it's 66.6 miles per hour. And when you look at the 666 comes up 10 times or 15 times in all mathematics involved with this globe Earth belief. And from someone with a religious base, firstly understanding that there is a great deceiver who's trying to deceive people, therefore you don't have the truth, that you are being deceived. Secondly, to see 666 show up 10 times or 8 times on just the most basic fundamentals of the globe Earth religion could put a question mark there. And then the fact that your eyeball is the thing that's actually causing the vanishing point in the horizon. Light travels in straight lines, but your eyeball concentrates it. So your eyeball is the reason you have a vanishing point. If you had a square eyeball, there would be no vanishing point. So because your eyeball is spherical, and it happens to be just sufficiently spherical that the 1.22 correlates with the diameter of a lens to the height of the observer to the distance of the horizon, implies that it's your eyeball that's creating that illusion of sphericity. So it's...
Does that mean, how does that work?
If I use an
So there would
instrument
be
to
no-
observe...
Excuse me?
Go, Rick.
I want to
If
hear
you use
both.
Sorry,
it
I
different,
someone else go.
if you use a
Wait,
different
well,
camera,
I want to hear
it's-
both.
it's-
Hold on. Solar, you did go on for a bit. Let's let Tarek and Daza both respond if we can, and then in between, if you want to respond, because I'd really like to hear both their points. Whoever wants to go first.
Daza hit it. I've got more of a question.
Yeah.
I'm trying to work out this square eyeball thing.
So a couple of things. So the eyeball thing, right? We can eliminate the eyeball as a coincidence by observing the shape of the Earth with an instrument that has a different aperture or uses different wavelengths, right? So that then we find there's no correlation between the nominal resolution of the eyeball and the position and distance to the horizon. The other thing I wanted to
just okay,
no,
like good attempt,
yeah.
but it's the 1.22 times the square of the diameter of the lens. So the diameter of your retina is one diameter. Take a different telephoto lens, and then you take the diameter of that telephoto lens and you times it by 1.22. So it does. Your point is moot because it doesn't matter what device you're using. It's still 1.22 times the diameter of the device you're using.
Yeah, but the resolution increases. But what I'm saying is so I can get higher resolution by increasing the diameter, and that doesn't change where optically the horizon appears to be. It's at the same angle and the same apparent position. So there's no correlation there. And the other thing that you touched on earlier was...
But there is, because as the diameter of the lens increases, times by the 1.22, the horizon is pushed back. So if I take a diameter
the horizon
of the
doesn't
lens,
move.
if I take a diameter of the lens of a meter, the apparent position where the sky meets the ground, which is the definition of a horizon, does move based on the diameter of the lens. So if I take a telephoto
angle is the
lens,
same, the distance is
see
the
the
same.
horizon
The
at
same
30
things will be
miles
obscured.
away. That's false. If I take a large telephoto lens, I can push the horizon back to 30 kilometers or 40 kilometers or 60 kilometers or 80 kilometers. But if I take a human eyeball...
That's factually incorrect.
It's mathematics, Daza. If you have a lens that's like...
And it's only mathematics if you think the Earth's flat. In actual fact, you cannot move the horizon by zoom.
It is it's not by zoom, by size of aperture or diameter of aperture. So you take the 1.22, which is constant, and then you take a variable, which is the diameter of the lens that you're using. So if the diameter of the lens is 6 meters, you go 6 times by 1.22, and you're going to have a larger distance than when I use half of a meter times 1.22. And this is the Rayleigh criterion. This is a physical
I agree
law
about the Rayleigh criterion. That works, right? But it doesn't change where the apparent horizon is.
But do you agree that if the diameter of the lens changes, your distance will change? Or you don't agree with that?
The resolution will improve. You may not see any further, depending on where you're looking. So if you're looking at the horizon in particular, you will not see any further. You might bring out detail that you can't see, but the position of the horizon in that image. So imagine you had a zoom lens is the same. The aperture of a zoom lens changes with the zoom.
But so what you're postulating is that because we live on a sphere, and we know that the horizon can be no further than 3 miles away from a 6-foot observer, it matters not what camera I use, the horizon will always be at 3 miles away from a 6-foot observer.
You didn't say that.
No, I didn't say that. No,
You're saying
the nominal geometric horizon doesn't change.
You're saying the horizon cannot change. So we know, based on your globe Earth maths, a 6-foot observer has a horizon at 3 miles away. And you're saying I can take out a telephoto lens, which can see 20 miles or 40 miles away, but it can't actually do that because the horizon's 3 miles and everything after 3 miles is behind the horizon, is your point.
Yeah, after and below. Yes, that's correct. So zooming in does not move
you
the position
agree
of the
with
horizon.
what I said, which is false.
That the Rayleigh criteria improves the resolution, yes.
It improves the resolution and thereby also increases the distance to the apparent position where the sky meets the ground.
No, that is incorrect.
You've never seen a photo from a 6-foot observer that's beyond 3 miles. So any photo you've seen
beyond 3 miles, but that's variable,
like
right?
Black Swan.
At a given point in
Black
time,
Swan was taken from a foot above ground level.
And
you can
the
see
Black
the
Swan
oil
is
platform.
a waste of our time.
No, it's not. Because
And
your
is
point
not
that you
to do with the Rayleigh
agreed
criterion.
to, but the point that you just
No.
agreed to is that a 6-foot observer will always have the horizon at 3 miles,
That's
no
not
matter
what I
what.
said. That is not what I said. You're putting words in my
You
mouth.
did.
I said
You said
at a given
everything
point in
past that
time,
point will be below and past that horizontal point, and that the Rayleigh criterion is simply about clarity. So I can see
You're-
clarity of nothing beyond the 3 miles from a 6-foot
so
observer. And Black Swan from
let me
a
rephrase that.
1-foot observer took
Come on, try-
photos
You
of an object
Try
60
and go
miles
back
away.
and forth, you guys. Come on. You
Yeah,
gotta let
and
him
real
go back and
quick,
forth.
yeah. Can I just hear though? So Solar, are you generally saying that the reason the horizon is what it is because it's where those two objects meet to one, basically the way the Rayleigh criterion? Is that how you're linking it? That the ground and sky are the meeting point of that, which is the 1.22, which is that the point at which the Rayleigh criterion, which they combine. This is kind of a short little side question. Is that what you're referring to though with it?
So the crux of that point was the 1.22 times by either the height of the observer or the square of the height of the observer gives you your horizontal line, or 1.22 times the square of the diameter of the lens is the Rayleigh criterion, thereby showing that the horizon or the horizontal point is simply optical. So your question, just repeat what your question was. I didn't quite. And you phrased it in a way that's kind of trying to link two aspects of what I'm trying to keep clear in my mind. So maybe
Oh,
I've
it's all
just lost
good.
your
It just
question.
has to do. No, it's all good. It was kind of just reiterative. It's just, I think we're on the same page, but I mean, it's the diffraction pattern that occurs with the Rayleigh criterion, which ends up being the meeting place of the ground and the sky. I mean, I guess it's like somewhat of a steel man, but I'm just trying to clarify is that how you're using the horizon as that like diffraction point. Like for example,
Correct.
here I'm gonna post this real quick. I think maybe Witsit, somebody had posted this, and then anyways, but it sort of shows like a basic diffraction, and then it just shows, the line there and then the meeting place. So I mean, essentially, you're equating that to being what the horizon is.
Yeah, correct.
Okay.
Because we know that height of observer does push the horizon line back, and that's why we always factor in height above sea level into our observations, because height above sea level is critical. If I gain 6 feet or 12 feet or 100 feet above sea level, I see the horizon at a vastly different position.
Right, because you're
But
creating
yet,
a radius. You're creating a radius essentially from your eye to the limit of.
correct, or an angle, yeah. But the optical side of things, with the Rayleigh being 1.22 times by the square of, it's both present in the lens. So whether I'm using a 6-meter large diameter telephoto lens, or whether I've got a 1/8 of an inch pupil, it's always related to 1.22 times the square of the lens that you're looking through. And then the 1.22 is also relating to the height of the observer. And that 1.22 times by the square of shows me that there's definitely something optical about where that horizon appears to be. And then something like the Black Swan, where you go down to 1 foot above sea level and you see 60 miles away, is the nail in the coffin for the globe Earth, because that would create a globe that's, I think it's 180 times the diameter of the current diameter of the Earth. So we'd have to have an Earth size that would extend past where the moon is said to be orbiting the Earth for that single observation, if the Earth was still a sphere. But the fact that it's a 1.22 times the square of, and then use X, whether it's lens size or height of observer, shows that the point of the horizon is purely optical. And if your eyeball was not curved in the way it is, we would not have a vanishing point. If we had a straight lens in our eyeball, the light would enter and not be refracted or not be converging to a single point at the back of your eyeball that creates the optical illusion of a vanishing point. Because the vanishing point is optical.
Can I push back a little?
Can I just?
Well, a couple.
I was first.
Oh, I know. Well, Daza actually originally was. I kind of brought this up as
Yeah, I just want to clarify
Leave it.
my point that was misrepresented. Then I'll drop out. It'll only take me 30 seconds, if that's right, or 10 even.
Yeah, go ahead.
So, under a given observation condition where we haven't got extreme refraction like the black swan, so we've got a nice, crisp, clear horizon, a classic horizon image, right? Changing the aperture of your lens will not change the apparent position of the horizon. It will be in the same angle. The same things will be obscured for any given observing conditions. Where that horizon appears to be is subject to a whole bunch of variables, but zooming in on the horizon, changing the aperture will not change the angular position of the horizon or where it physically appears to be. That's it.
Yeah, well, if Solar's going to respond, I imagine he would agree, but if he's at his mic.
No, that's absolutely false, because when I start to zoom in, I look out to the ocean, and it appears like the horizon is somewhere between 3 and 5 miles away. And then I zoom in and zoom in and zoom in, and suddenly I see a boat that was not even resolvable when I was standing on the beach. And then I still see the horizon past that boat, which was not even resolvable at the beach level. And that's due to
the
a
horizon,
zoom,
then, are you?
which is increasing aperture size. And as I increase the aperture size times by the constant of, or the square of that aperture size times by the constant of 1.22, does give me a greater distance. If I'm increasing something and squaring it and timesing it by the constant of 1.22, it will always give you a greater distance. And that's why there are millions, or let's say tens of thousands, of flat earth videos of people standing at the beach. You're looking at the beach, you see a horizon level, and then you zoom out, or zoom in, zoom in, zoom in, zoom in. And eventually you see a boat that was not even visible from where you were. And then you can still see the horizon past that boat level. Whereas when you were standing at the beach, it appeared like the horizon was 3 to 5 miles away, because you were only
I can
looking
observe the
through
horizon with my
aperture of
naked
your
eye. I can see ships go over the horizon with my naked eye and be truncated. And I know that zooming in on those ships will not change the amount of ship that I see under those conditions. The horizon does not move. It does not change the scope of what is visible. Details that I cannot see will come in, but the things that are below the horizon remain below the horizon when I zoom in.
Then you have never looked at any of the tens of thousands of flat earth videos.
I have, and you're completely misrepresenting what happens.
The only one that I've seen, they zoom in and a boat shows up, a small vessel shows up that you couldn't see, but it's just because it's too small to see. It's a little fuzzy too.
Yeah, this is kind of a both and situation. I feel like because there's 2 points to this. There's one where you just don't have the resolution. Therefore, if you can zoom in or whatever, maybe you can get more resolution. Therefore, a boat that wasn't visible will then be visible. But then there's another scenario, like when you have that actual optical obscuration point, like what they call boats cutting off from the bottom or whatever. There's nothing like if you have that strict cutoff, there's nothing that you can do to make that not happen, like by changing lenses or zooms. So it's kind of 2 things. One of them,
set a time for 8 minutes.
Yeah, so it would, just to reiterate, he's hot micing. I think he's hot micing. No, I'm just saying, so if a boat is there and it's not cut off from the bottom up, but you just can't resolve it, that's where zooming in, you'll be able to see it when you otherwise couldn't. But it's not because the cutoff is changing, it's just because the zoom and the resolution and so on is changing. However, if you have that cutoff point, leaving aside what that's caused by, I'm just saying, if you have that cutoff point that's very, very, very slick, I mean, changing altitude might change it, but other than that, there's nothing with optics that would be able to make that disappear, that cutoff point. That's what I was saying. So do you guys agree or disagree with those 2 delineations?
I agree with you, Jim.
Yeah, I agree with you in principle, because a wave or like a hump of water that is close to you can cause obscuring of something very far in the distance. So I 100% agree. If it's actually obscured because water is in front of you and the observation, no lens can bring that object back if it's already obscured. But again, due to perspective, I can put my thumb in front of my eyeball and block the whole world out. And my thumb is just less than half an inch wide. But if I held my thumb at a certain distance, it's not going to block the whole world out. So if I'm taking a low elevation observation and there's even a 1 foot wave between me and the boat, that 1 foot wave at, call it 10 feet away from me, could block an entire mountain, because that 1 foot wave is causing a blockage in your visibility to an object in the distance.
So if you
But
hold it up at your waist,
the
if you
horizon,
hold your thumb up at your waist and see if you'll block a mountain. The water's below your line of sight. Therefore, a 1 foot wave is not going to hide anything in the distance.
it can hide the bottom of something, which is why you guys tend to presume that things are disappearing bottom first. Because when we're taking long distance observations, it's generally over the ocean, where you have not only swells, but you have a peak, a crest, and a trough for every wave cycle. And certain swells are sometimes 6 feet or 8 feet or 10 feet. And if I put that object when I'm taking a 1 foot observation, and the peak or the crest of that swell is 3 or 4 feet high above my 1 foot observer height, you are now creating an obstruction for things in the distance, especially from bottom up.
We need the rumpus.
Well, the issue with that is that we are not restricted to viewing things at sea level. And what I think is being done is that you are, for whatever reason, I don't know, but you are insisting on stopping your investigation at observations from sea level. Typically humans, we don't just stop at one and say, okay, job done. It just looks like that and we don't have any more investigation. We've moved on from looking at the horizon. We moved on from that a long time ago. So if we were restricted at the horizon, then okay, you could make a case, but we're not. I'd like to know why you keep on staying at the horizon. Job done. It just looks like that, and we don't have any more things at sea level. And what I think is being done is that you are, for whatever reason, I don't know, but you are insisting on stopping your investigation at observations from sea level. Typically humans, we don't just stop at one and say, okay, job done. It just looks like that, and we don't have any more investigation. We've moved on from looking at the horizon. We moved on from that a long time ago. So if we are restricted at the horizon, then okay, you could make a case, but we're not. I'd like to know why you keep on staying at the horizon.
Because it's deriving the distance to the horizon formula is 1.22 times the square of the height of the observer. And the Rayleigh criterion is 1.22 times the square of the diameter of the lens. Thereby, the distance to the horizon formula is optical. It's that simple.
Here's a question. Is there a limit to how far we can go up and view the Earth?
In a downward trajectory, or
yeah, I mean, obviously when you go up, you'd have to look down. I'm sorry, it sounds sarcastic. I don't mean to, but yeah. So you're going to go up, and then you look down the Earth.
All right.
Is there a limit to how far you can go up?
What is the Guinness World Record for long distance observation?
No, not what I was asking. Sorry. I'm asking: is there a limit to how high we can go up before? Is there a limit to how high we can go up to look at the Earth?
And the answer is no, and that's why I asked you. Do you know what the Guinness World Record is for long distance observations?
I don't know the exact. Can you tell me the elevation that the observer was when that photograph was taken?
It's irrelevant because your question was,
It's not irrelevant.
Can we go up and still see further? And the
It's
Guinness World Record currently 275 miles
right.
from the top of one mountain
There you go.
to another mountain.
Right.
And on your spherical model, the other mountain would be completely obscured by curvature. Could be.
Ignoring refraction, yes, it would. But we don't ignore refraction.
Then using what's that lens called? I don't know if it's not ultraviolet. Or is it a UV lens?
No.
Infrared. Yeah. With infrared, they've captured mountain ranges at 800 or 900 miles away from airplane altitude. And then when we go up even higher than airplane altitude, we see distances that are equivocal to 1,000 miles and 1,000-mile plus. So your question
You're referring to J-Tolan media, and that none of that information has been verified. Just to because I know what you're referring to. That's J-Tolan.
No, if you've actually watched it, it has been.
I did.
According to your anti-flat Earth priests, they will say hasn't been verified. But when they actually demonstrate, they show an overlay of the mountain ranges, and then they show the video footage that he took, and you can easily correlate that the mountain range that he's postulating is the one that's demonstrable. Your anti-flat Earth priests will say, no, unproven, and then you guys will continue to parrot unproven, even though demonstrably proven, but you can continue to postulate not proven.
Okay, yeah, I will, because there's nothing scientific about that in any way. Putting it just showing a camera picture and then saying that is scientific proof that these are the mountains. That's not been confirmed scientifically in any way.
I never claimed scientific evidence. I said demonstrably proven.
But it's not demonstrably proven. That's the problem.
As in demonstrably. Scientific method implies that you've got a variable, a independent variable, and a dependent variable, and thereby you wiggle the dependent variable and cause a variation in the result. There is no independent and dependent variable in terms of an observation of a mountain range. And when you're taking an observation of a mountain range and you have an overlay of that mountain range, and you can see it correlates that the observation of the mountain range is the mountain range that's being observed, you can continue to put your fingers in your ears and go, nah, or you can just accept the fact that it's demonstrated.
I can apply the same skepticism that you apply, and if I do that, I can very, very easily conclude that those have not been demonstrably demonstrated in any way, simply by applying the same skepticism that you apply to observations that we make.
Are you looking in the live stream now?
Yeah.
Are you looking in the live stream now? Can you see the images of the people where they've gone through the time and effort to go and literally point out every peak in the entire mountain range?
It sounds convincing because
not sounds. I'm saying
it isn't convincing. The problem is that you have to convince skeptics. And
the thing is,
you're saying that and just label people, with priests and parroting. It doesn't do that.
But here's the thing, guys. Here's the thing. Listen, Solar. Let me say something. The thing is, a mountain range. Hang on, Solar.
When someone's showing you the picture of the black swan and you're saying not a black swan, and someone's showing you the picture of the black swan and you continue to say it's not a black swan, when you can easily look at the picture and confirm for yourself it is a black swan, you continue to parrot that all swans must
Stop
be
insulting.
white
Yeah.
is
Here's the thing.
religious. That's
Here's the
not
thing, Solar.
insulting. I'm being quite
Maybe he's
blunt.
got me turned down. I don't know.
You may
Maybe
Go ahead.
I don't know. The thing is, if you look at say a 15,000 foot mountain, the angular size of that mountain at a fucking 1,000 miles away, you couldn't discern any peak of that mountain. It's so small that you could not tell it's a mountain range. That's ridiculous.
Or you can use infrared as per the demonstrations
That don't
in the
change
live
angular size.
in the live stream. Yes, and it's all proportional. That's the amazing thing about these observations, is that it's proportional. So you can look at the mountain range and you can see, and someone has gone through the time and effort to actually go and label every single peak in the mountain range
He couldn't
that is
identify it that
observable
far away.
at hundreds of miles, and you can continue to say, no, it's not.
Yes, we will continue to say no, it's not.
Or you can simply look at it and then go and do your own research. You know, there's this thing called your own research, or you can continue to parrot what your
been done.
priests say.
Yeah.
No,
Our own research, like going to Antarctica and going to orbit and sending up rockets and sending up balloons. All of those things, doing our own research.
Long distance photography. And your question originally was, as we gain altitude, can we see further? And the answer is demonstrably yes. And if we use infrared, we can even see further. And what is that distance? The Guinness Book of Records says 275 miles, which is close to 400 kilometers. Where should your horizon be on your globe Earth?
Can you steel man our position then and tell us how far it should be, including refraction, without ignoring refraction?
Based on the observer height, you should not be seeing a single mountaintop.
I disagree. What he was seeing was clouds.
They
and
should
you can't prove
all
otherwise.
be included. They should all be occulted behind an apparent horizon line, which you said is a physical, tangible place. And everything else should be behind said horizon line when it's not. And as you gain altitude, you can see further and further and further. And then at a certain point, the actual atmosphere starts to block out what you can see, and thereby using UV filters and other types of filters, you can cut through that opacity and you can actually see what's there. And like I said, you can go and pull up any one of these images, go and search the mountain range yourself, and you can see that what they've presented as the mountain range is what you're seeing, or you can continue to parrot what your priests say.
Yeah, it is a Guinness Book of Records,
and you can
by the way, ladies and gentlemen.
You can
a Guinness Book of Records. Hang on a second, I'm talking. It's a Guinness Book of Records. And sorry, I cut off earlier on.
Why do you continue to do that? It's very interesting because you don't think of it as an insult.
You can hear me talking,
That must be what it is. But your audience is skeptics, not other flat earthers. They are skeptics. And if you talk to them in that way, you're going to eliminate their interest and their receptiveness to your information. So why do you continue to do that? I'm very interested.
There's a difference.
Please tell me. I'm interested.
And a denier.
Why are you continue to do that?
Denying. No. There's a difference between a skeptic and a denier. A skeptic is skeptical until more evidence is presented. A denier, such as yourself, will continue to deny regardless of the evidence presented to them. So when we show
good evidence,
when we show you the exact
treating it with the same skepticism that you would treat our evidence. That's not denial. I could call you a denialist because you deny all the evidence that disproves flat Earth.
Yeah, can I just say real quick? The whole thing. Yeah, can I just say one thing about denying? People always write that off as if it's some kind of like just something that people are just saying no. But generally when people don't agree with something, they have reasons for it. So it's not really just like a blind denial. Like they have some reasons as to why they think that. You know, because either quote unquote side or anyone could call anyone else denying anything. You know, like if let's say if I disagree with someone, like I think vaccines are toxic and they think they're good, and then if they don't agree with me for whatever reason, if I just said, well, you're denying, I mean, yeah, but they have reasons for why they do. So I guess it's either like those points need to either be addressed, and then otherwise, just like I just don't see the benefit of saying someone's denying, because they're either denying for a reason, and then we could talk about the reason.
Yeah, that's a good point.
Otherwise, I
Yeah,
don't really see anyone just out of the blue just saying no. Like, do you guys see that? Like, is anyone really just like no for no reason? I mean, generally it's like no because this, and that. They have a whole.
I agree with you in principle, Gio. I agree with you in principle. But an intellectually honest individual, when presented with something that is substantive, could say, "Wow, that's interesting." A denier,
I tell you what. Sorry,
will be irrespective of what you present. So you talk about the vaccine. So you show a skeptic / denier information about correlations where they've done scientific studies about the correlations of side effects with that medication, and they'll go, okay, that's interesting
for you.
But I still disagree with you. And then when you present the second piece of evidence, they go, you're starting to build a case. And then when you show them the third, fourth, fifth, sixth, 10th, 30th, 100th piece of evidence, a real skeptic will say, wow, you've really given me something to think about. A denier will say, I don't care what you show me, I'm not agreeing with you because you're wrong. And in that instance, that's when I'm saying denier is someone who's denying something that's blatantly obvious. No, they're denying something which is blatantly obvious to them, like the flat Earth. Like it's observable. We all experience the Earth flat.
You're treating it as denial because we've never had this conversation before. So what it sounds like to you is that I'm just blanket denying it. I'm not blanketing denying it. I've seen multiple people look at the evidence. If you're suggesting that you can do an observation and have nobody analyze that observation uncritically, and you can just accept it uncritically without accepting any criticism of your observation, then you're not doing science. The essence of science is that you do observations and you subject your observations to critical analysis. Otherwise, it's of no worth, because you're just saying, "Oh, I did this thing," and it was, "Oh, you really did this thing? Cool, great." And then, but you can't prove that you really did this thing, so you have to be skeptical.
1000%, I agree with you. 1000%.
So you're saying that anyone who denies it, who says that it's been scrutinized, but those observations have been scrutinized and they've been shown to be faulty.
They've never been. This is the point. Your priest.
Oh, that's denial. He's denying it. He's denying it. It has been scrutinized.
Your priest have told you you don't need to acknowledge that piece of evidence because it's false, without ever demonstrating how it is false. And then you believe them and say it's false. And then they post the image. You can see the damn image yourself. You can look at it with your own eyeballs. You can see the mountain ranges. You can pull up the mountain range. And then you yourself can either validate or negate what it is that you're actually looking at. But the denier says, someone else told me I don't need to acknowledge that.
Come on, bro. Just make it a little more concise. What exactly is the claim on the table? Because you guys have been going back and forth.
It's the claim is you can see too far, because there's a Guinness World Record observation, and it's from one mountain peak to another mountain peak. If you ignore refraction, you can say you see too far. But if you include refraction, because refraction exists in the atmosphere, you can't see too far. And the other thing is, Jay Tolan very carefully tried to make the correlation between the clouds that he saw in the distance and the tops of mountain peaks from 200 whatever miles away. And you can't do that. That's not scientific.
Okay.
Looking at a photograph and trying to see mountain tops in clouds.
Rick, I'd like to respond to that.
That's not scientific in any way. So
I'd like to respond to that. So you say refraction is the reason why we're able to see said mountains from a certain distance. Is that
refraction? Yes.
Okay.
It exists. Does it not?
So so if that's your claim, then when we use an infrared filter to basically reduce the refractive effects, how does that make sense?
Because I don't think that's what they do. They just cut through interference in the atmosphere. They don't necessarily reduce refractive effects.
Yeah, no, it's exactly what infrared does.
And you're trusting the word of a guy who made one video.
No, not trusting him.
No.
We're just looking at his evidence, dude. That's all we're
trusting.
doing. Okay?
That's
not
trusting.
Hold on.
It's exactly what it is. You're doing the same thing we do.
RedCloud.
Yes.
I'm talking to you directly. We're talking about infrared.
Right.
Do you agree that infrared is not that wavelength is not affected by refraction the most? There's it's barely affected by refraction.
It's the least affected. It's the least affected of the.
It's the least affected. So if your if your claim is that we're able to see that far and make it look flat based on refraction, right? With these long distance observations, then how does that make sense if we add an IR, an infrared filter, to cut out refraction, and then we can see further?
See, you can't cut it out. You're going to have to do a comparative analysis to see how much does it change the refracted image.
Can you see further with infrared?
The problem what I'm trying to say is there's no science.
Can you answer that question, please?
Can you answer
the question, please?
There is no science being applied to this. You're just seeing that and saying that's good enough for me.
Red, can you answer the question, please?
Science is a religion.
Can you see further with infrared?
This is a religion. You're literally saying you would die on this hill.
I'm asking you a
question. This is your religion. Don't go there.
Guys, we need to just reset. Hold on. Everybody, hold on for a second. I'm going to mute everyone who needs to be muted. All right, just hold on for a second. RedCloud, you're kind of all over the place. Your mic's open a lot of over talking. Can we chill out? This could be a really good conversation. There's a lot of it's a good vibe here. So can we just go one at a time, make it clear, let people respond, maybe try not to have any side commentary, and anyone else who wants to get in can get in as well. But these guys are kind of. But please just RedCloud, try not to talk in between people and talk over people. Let's just.
You got it.
RedCloud, please just answer the question. Can you see further with infrared?
Yes.
Okay.
Is that calculable?
Then your refraction claim doesn't work.
No.
If we can see further with infrared, and it's least refracted, that wavelength, then that doesn't make any sense.
It does if you can calculate it. You haven't calculated it. Where is the calculation?
So RedCloud, as far as the calculation is concerned, the refraction throughout the day, right, and night, and all the variables changes, and thus, isn't it kind of curious to you, dude, that we're told about the limit of our vision is essentially the reason for it is the fact that the Earth is curved, but then it turns out you find out, oh wait up, that horizon is getting further away and coming closer to me throughout just the course of the day. They don't tell you that. They just this is the thing, it's kind of, they just lead you to the assumption that you're, the limit of your vision is caused by Earth curve. But now when you start getting into these discussions deeper, you're like, oh, wait up, it's actually an optical phenomenon caused by the limitations of your eye. And it changes due to conditions. It's crazy.
The problem is the lack of scientific rigor.
So you keep
it is completely devoid of scientific
calling it a religion.
You're doing that because you're doing that and you're labeling with the pejorative of religion. Are you religious?
Can I make a comment on the infrared light?
If you are religious, if anyone here is religious, and
I'd like to make a comment.
I'd like to make a comment. You're disparaging religion.
All right, guys, one at a time, please.
That's
productive. RedCloud, you got to give people some breathing room here.
Well, maybe at this point, maybe RedCloud, maybe let some of these other guys get into. I think Gatebreaker and someone else.
Yes, thank you.
Gatebreaker and Jin.
I was commenting on what you guys just said about infrared light. This is from what I understand. In the global model, with light bending down to the more dense gradient, causes light to appear higher the more there is refraction. So if you use an infrared filter and cut off those wavelengths, you shouldn't see further, because those wavelengths that you're cutting off is what is making you see further. So it's actually backwards. And I can repeat that if anyone wants me to repeat it.
No, it's a good point. It doesn't make any sense if we have long distance observations that basically make it so that it appears flat, right? Like, wow, that's pretty flat out there. Oh, it only looks flat because of refraction. Okay, let's use infrared. Wow, I can see further with using a wavelength that's least like the least refracted. That doesn't make any sense. So how can they continue to say refraction as this like unfalsifiable claim that they just parrot? It's unfalsifiable.
So again, specifically the issue is in their model with light bending down, it makes things appear higher than it is. So the more refraction they have, the more downwards curvature of light they have, aka refraction, the more the consequent of that light taking a non-straight path, it makes it appear where it's not. Okay, and though appearing where it's not in their model in standard conditions, it appears higher than where it is. So you would point to it in their model, and it's not actually specifically there because you're seeing like a warped, refracted. You see what I mean? So they're claiming in their model, and this is what happens in reality. If you pop an infrared filter on your camera, they're claiming in their model it makes them see further. But again, that doesn't make sense. Why? Because what an infrared filter does is it cuts out wavelengths of light in front of infrared. So red, green, and it cuts those out so you don't see it. Those ones that you're cutting out refract more. So they're cutting down the effect of refraction in their model, but it's making them see more than what they're supposed to see. That's backwards. So that's all. Thank you.
Thanks for that point. That's a great point. I just want to say thank you to Flat Earth Sold Up for bringing up that picture. That's 275 Guinness Book of Records. And J. Tom Media brought up two very important things there. And remember, this is coming on the back of we are not able to measure this curvature because of these events that are happening, these long distance observations. Remember, circumference means circular. Circumference, 24,901 miles circumference. That means if I leave Australia, or should I say UK, and go to Australia, following the curvature of the Earth, the circumference, I should go upside down. It doesn't happen, okay? These are the reasons why. There is no curvature. We are living on a flat, straight, stationary plane. That's why we can see further than the curvature would allow. We're not experiencing the curvature here. I should stop there. And my last apology. Sorry I cut off earlier. Device battery died. Sorry about that. And that's it. Thank you.
Just to summarize, like how we got here was we were talking about distance to horizon and how it's 1.22 times the square of the height of the observer. And then we started talking about as we gain altitude, we can see further. And then they argued that no, that's irrelevant because the horizon is a physical, tangible place. And then I asked them, where is the Guinness Book of Records, or at what distance is the Guinness Book of Records for long distance observation, which is currently set at that 275 miles, which is almost 400 kilometers. And then we started talking about Jay Tolan, where he's got observations of 500 miles, 800 miles of the Rocky Mountains, etc., and that he's using infrared to see at those distances, that he takes an overlay of mountain ranges, and that you can actually, if you are so inclined, you can go and look at the evidence yourself, and you can go look at his evidence, and you can determine that the mountain ranges that he's observing and showing for you are the mountain ranges in question. And when everyone started to post infrared images of mountain ranges at distances you shouldn't see, they denied all that, saying, no, it's already been disproven that those mountain ranges are irrelevant and that you don't even have to look at that evidence. And that's where we got onto this topic of saying, how can you just deny the evidence that's in the live stream text? Like, go look in the live stream text. Someone has gone painstakingly identifying every peak of an entire mountain range. And if you go pull up the mountain range yourself, you can see that the peaks follow almost perfectly the mountain range that's being shown to you. And they say, no, their anti-flat earth priests have said you don't have to acknowledge that evidence and that it's all fake.
I don't know. Fuck, man, why do you keep doing that? Anti-flat earth priests have told him to ignore it. That's bullshit.
Therefore, we don't have to. We don't have to acknowledge the thing that's right in front of us. Like,
I'm not going to acknowledge you. I don't think we need to acknowledge you.
Left lane, don't feel offended. He didn't say your name, so chill out.
He's referring to us while we're in the room because he doesn't care.
So you guys identify as flat earth priests?
Why is that okay?
Anti-flat earth priests?
I want to know something human from you. I want to know something like a regular human would want to know. Why do you think that is all right? While we're in the room, just say stuff like that.
You've been
It
rude
isn't
yourself,
I'm-
RedCloud. You've been
I'm
rude
It
yourself,
isn't all right.
RedCloud. You've been rude.
It's called contextualizing how
No,
we
it's
got
called insulting
this
your audience.
redundant point. And if you want to take offense to something that wasn't directed at you specifically, you're welcome to, brother. But
It
what
is
I was
directed
saying
at
is
you.
that if I show you a photo of a black swan, and you want to continue to parrot that there are only white swans on this
Oh,
earth,
good grief.
and I'm showing you a photo of a black
Now he's going to
swan,
lie about it.
you can continue to claim there are only white swans, and your priests have all told you that you
Nope.
don't
He's
need
just
to
going to continue
acknowledge
doing
No,
that.
he's
It
gonna
doesn't
get,
even
yeah,
matter.
he's just going to keep right on doing it. No one's ever said that there are no black swans.
It's going to be our policy to just talk to you in the way that you talk to us. Do we do that?
100%.
Well, that's what
That'll
you've been
make you
doing, though.
feel
We
better.
wouldn't last 10 minutes in here. Gio would kick us out.
No, you guys, let's just all chill out for a second. Flat
Well,
Earth Solar,
you
let's
need to
stop
ask him
using
to stop
anti-flat Earth,
insulting.
please. We'll just not use that. We'll just say anti-flat Earthers because we can say that's accurate. You guys are anti-flat Earthers. You're not just normal everyday Globers. You guys heard these arguments over and over and over and over. You're basically anti-flat Earthers. You're chilling in a flat Earth server. So
Yeah, I'm not
sorry, you guys
anti-flat
take
Earth.
offense.
I'm not
We're here
anti-flat
for the
Earth.
heat.
It doesn't
Yeah,
matter how
come
many times I repeat that I'm not an anti-flat earther. I still get called an anti-flat earther.
What, you're so pro-science and you see a couple of guys not practicing your so-called scientific method, you got to come in and talk to them?
I just don't think you. I don't think you just. I think you are so hell bent on flat Earth. You literally flat Earth focus guy said
I'm actually
he
not,
would
bro.
he would
I don't
die on
even-
that hill.
I don't
You,
really
and now
claim
you're
the
just
Earth
going to
is
say you're
flat.
not.
I claim
like
that
the
we
fact
are
that
being
one of you guys just said he would die on that hill. Mark Sargent said he
It's
would
up to
die
him.
on that hill.
They're individuals. They can make up their own silly decisions, just as I have done in the past.
They can make up
you
their
know,
own positions.
That's not even. If you want to go there and just talk in that way, we can talk about way and put in those things. He just says this stuff, and you expect us to accept it.
No, you don't have to accept it, man. You could Discord and disconnect from the Discord, okay?
Oh, okay.
You don't have to accept anything. It's up to you. It's like I chose not to take the jab, right? I just left it. I don't want to take any part in their bullshit. So
Here. And don't forget, no one's addressing the point that I raised, the circumference, and why we don't go upside down if we're supposedly following the curvature of the Earth. I mean, you can't have a circumference without curvature, and you can't have curvature without circumference. So that's your problem there. That's a problem for you. You've got to follow the curvature of the Earth. Why do I not go antipodal when I'm going down towards New Zealand and Australia, following the circumference of the Earth? Why is that? Why don't you address that? Come on.
How long have you been here, Jen? How long have you been here?
like
Yeah, I mean,
There
even
are
I
so
could
many-
I could
Point.
even
Don't
rebut
ask me
that
a
for
question.
the globe
Address
side.
what I raised, please.
Yeah, I could address that for the globe side, but does someone else want to? I mean, that's just how their model works. Down is down comparison to the center of the earth. So as you travel upon it, your down constantly essentially changes to make down always just seem like it's down, which overlaps with the geometry of what would happen on a stationary plane. Down is
the
always
anomaly
down.
is
I have a question.
there
for
are
Solar, if
differences
I
Like
may.
that.
between the north and
Wait,
the
one
south.
sec.
I'm just saying that part of it, down is always down.
Yeah, if you don't mind. So I have a question for Solar. He said, we just deny the evidence, and if someone shows the evidence, we just go, no, it's not happening. It just lies or this and that. So if I was supposed to take that infamous picture of the oil rigs, but Black Swan or Flat Earth, if someone showed that to me and says, okay, oh, look at this picture, we can see too far, and look, it's great, it's proven. And if I look at the picture and say, okay, fair enough, and I look at it, I say, let me analyze that picture. I look at that picture, I go, hang on a minute. I know what oil rig looks like, okay, and I know what is the structure will look like. These cranes are all wonky. Why
Yeah, but
is
that
that?
is-
Oh, it doesn't
yeah.
matter. Let me finish. Okay, let me finish.
Oh, I
And
thought
I
you were
go,
finished.
this person goes,
Yeah,
this person
there's
goes,
distortion. There is distortion.
Exactly,
But can I just
there's
clarify
distortion.
one thing though? But it's not really about you can see too far. It's that the horizon
What the horizon
is
Yes,
correct.
no, I
not in
understand.
the
I
position
understand.
of what it would be if it was a globe. Yeah.
Fair enough. I understand that. But my point is, and I go, okay, this thing, why is this thing happening? And it doesn't make sense. And I go research and it goes, oh, there's this thing called refraction. What is refraction? And I study about refraction and it turns out, oh, reason I'm seeing too far, the reason I'm seeing these oil rigs in such a shame, or like I said, the horizon is because of refraction. Therefore, the reason I'm seeing too far is because of that. Then, therefore, the horizon is where it's supposed to be. It's only happening because of refraction.
But that's an
Am I hang on,
unfalsifiable claim, though.
am I denying anything at this point?
So
Am I denying
there's
anything?
2
I'm just
points.
going, this picture
There's
doesn't
2
make sense
points about this.
because of this. So
Do you understand
Hold on,
that
I'm
hold
not
on,
oil
you
agreeing
guys.
with
rig?
That
Craig.
was for solar. Hold on, you guys.
I
That was for
haven't.
solar.
I haven't.
You got everybody. Hold
Yes.
on for a second. Let's let Hammerize and Solar go back and forth. So yeah, let Solar respond because it was for solar. So let those.
Go
So
ahead.
let's
Go
let
ahead,
these
Solar.
guys go back and forth for a few minutes, however long they need. Go ahead.
100% Hammerize. Like what we always say is go do your own research, come to your own conclusions. Don't ever believe anyone in this room. Don't believe anyone that's an anti-flat earther that's telling you to believe something that they postulate. Firstly, with that observation, the entire point of the observation was where is the location of the horizon before or after said platform. That was the point of that observation. It wasn't what do we see in the observation? What objects are we seeing in the observation? So again, it's a distraction technique to try and say, let's talk about the oil rig when the entire point of the observation is distance to horizon. Secondly, oil rigs generally have a heat source. They're normally burning off natural gases that come out when drilling. So if you've ever looked through a fire or an open source flame, there's a lot of distortion that happens around the flame point. So round about the top of the oil rig, it's expected and anticipated and pretty demonstrable that those little poles that stick off to the side that are above the heat source where the flame is being ejected to release the natural gas, that optical illusion that you're seeing is heat related and not refraction related. But
It
the
is
crux of the
refraction.
point, no,
Okay.
it's heat distortion. So any observation above a heat source is going to appear exactly the same way, but the point of that observation is distance to horizon. It's got nothing to do with the platforms. So
It does.
look
It
at
does
the image
highlight.
again.
I
Look at
have.
the image again. Ignore the platform, as in, do not even look at the platform. Simply look at the horizon.
I
Is
cannot
the
because I
horizon
need to include
before
refraction.
or
I need to include
after
refraction. I
the
need to include
platform?
refraction.
Hold,
Okay.
hold on. This question. Did you hear his question though?
Yes, I have.
Because
He says,
the
sorry, go on.
the the feet
All right,
the
all right,
feet
Wait,
of
wait.
that.
Solar.
Flat Earth. Flat Earth.
With
Flat
all due
Earth.
respect,
Ask your
Solar,
question.
Solar. Yeah,
But let
with
me
all due respect, just can you pass the mic there because you said a lot. We got to keep it
but
somewhat
let me
concise.
just finish. Let me just finish the point
You got to keep it
because
concise,
Well,
bro.
like a game of tennis, dude, back and forth. Because there's a bunch of points that I mean, to be fair, for you to
100%,
okay.
100%, I agree. But the base, the feet of that platform is not distorted. It's only the top where the heat source is that's causing two lateral poles to appear distorted. The base of that platform is not distorted. So therefore, presuming the horizon would be distorted in a band or a region that's not distorted at all, and we know that the platform's giving off a fire source, a heat source, which is causing refraction or distortion above the platform when the observation is only about distance to horizon, is disingenuous.
Well, ask your question again though, because I don't. You said it and then you kept going.
No, I understood. I understood. So here's the problem.
His question is,
Proper
where's
good.
the horizon in the photo? That's what he
Yes,
said.
but here's the thing. So we analyze the first picture. You go, okay, surface suspicion going on. By the way, you are ignoring refraction. I do not understand why, but let's play your game, okay? Here comes the second picture. The bottom you're referring to now is different. The bottom that those what you call it stands, whatever you call it, now in a different place now. Why is that? Different time of the day. It's the same platform. Different time of the day. Someone else took the picture. Can you explain that then?
Where is the horizon?
Yeah, that's the
Is the
question.
I'm literally. I know. I'm talking about the horizon.
Okay, where is it in the photo? Is it
I mean,
behind the oil rigs?
There are two or three pictures. Okay, I will put in the chat once I get them. Okay, 2 or 3 pictures. My point is, one oil rig, if I'm not mistaken, I've seen this picture some time ago. The first one is kind of the two, kind of one sit at the one on the right is in the bottom, the one on the left on the top, or vice versa. If I'm not mistaken. There's a white swan version of it, which is kind of a other way around, where the back one is kind of lower than the third one in the front, or vice versa. I can't remember the exact things in my head. That exactly explains that exactly says what that exactly says what we think will happen based on the refraction.
What?
And with the long shot photos, again, you ignore. Okay, let's go back to the oil rigs. We've got 2 different pictures. Are we basing off just on one picture, or are we just basing off on second picture? Because the second picture is much different to the first picture.
Wait, is this your response to everything Solar said, Hammerize? Because he laid out several points.
No. I know his response. His question
Well,
is
it was
maybe
about the
where's
distortion,
the
about
horizon?
the heat, about where the horizon is, about how the horizon is not distorted. The parts that are distorted are
Let me
where
get
the
pictures.
platforms are. Okay, all right.
It's just a cog diss, bro, at this point. This is crazy. Just answer the question, or at least address the points.
Well, it's just... Did he say he had to go for a sec, or are you still there? Go ahead.
Can't hear you if you're talking.
Yeah. Hammerize. Maybe he dropped out is what happened. Maybe he got a phone call or something. Yeah, he probably did. All right.
It's pretty simple. It's just a simple observation.
No, I was interested in his point too. Like he brought up a whole second point, but he has to we have to figure out which photos he's talking about. Like it's just like he went on a second point, and whereas Solar laid out all those things. So sort of, I was expecting to hear a response to that.
Again, his second point was, let's look at the rig. Let's look at the oil rig. And the point of the observation is distance to horizon. And they don't want to talk about distance to horizon. They want to talk about the oil rig. So even in his second point, it was, let's look at the legs of the oil rig this time. And it's like, no, stop.
Yeah, here's the equation.
Something that's irrelevant. The oil rig is a distance marker. That's the only purpose that it's in the photo for.
Right.
Well, I was backing him up and posting stuff.
Can I ask Gio a question? Gio, a question when you're ready.
Oh, hold on, Jed. I was just saying I was posting stuff in chat because what he was saying I think is just a whole separate point. So that's why I was just asking him. Did he have a response? I was just asking. Well, he cut out, but that's what I was saying. Is this a response?
He cut out.
Solar had said.
Yeah.
But
Can I address something before Jen real quick? Just real quick. All right. So in the global paradigm, is the horizon optical? Is it apparent? Or is it physical? Right? If anyone wants to answer that, that's a Glober, they can. Go ahead. They say it's both. Okay. How can it be both? It's either a physical geometric horizon that you can point to, or it's not. Our position is that it is just apparent. So when you see this observation of the horizon way beyond the limit, that it's supposed to be, if it's supposed to be 1.22 miles, if 1 foot off of the ground, then how can you just say that that's that's just refraction? It's just an unfalsifiable claim. Like, it's just refraction. Yeah, it's supposed to be.
What about all the other images, though? What about all the white swans? And as far as describing if physical or apparent, it is the physical geometry that is, that causes the horizon, and that it presents to your eye through a refracted beam of light, makes it, display somewhat, and that's why we call it the apparent horizon. It's not a question if it's physical or not physical. That's kind of a strange question to me.
Is it physical or not?
Left Lane, can you explain Canigoo Mountains when the sun silhouettes is refraction? Is it refracting up the silhouette, the shadow as well?
Yeah, the light that's coming around the mountains refracting just like anything else would.
But guys, shadow cannot be refracted.
Getting the point that Gatebreaker brought up was that refraction always moves downward towards the more dense medium. So when you guys invoke refraction, It should be a limitation on your vision. It should be causing a reduction in observation distance, not an elongation in observation distance.
Exactly.
No,
Good point.
downward light causes things in the distance to appear higher. Everyone knows that.
How?
And
How?
refraction cannot.
Is your real name Ron White by chance?
He sounds like Ron
He
White.
sounds just like
Hilarious.
Ron White. I don't mean to
Who's
poke
that?
fun. He's like a
Who's
famous
that?
comedian. You sound exactly like him.
One. Guys, can you hear me now? Oh, am I back online?
Oh, there you are, Hammerized. Yeah.
Sorry to derail. I just thought it was funny.
You know what?
Yeah,
I
no,
don't
okay,
know.
yeah. Hammerized, you are back, and we can give the mic to you because, yeah, I guess, yeah, you cut out, or maybe you got a phone call or something. So
No. My mic is really playing up. I put the pictures in the chat.
yeah.
I don't know what's going on with me. What was no microphone tonight? Guys,
Is refraction? Is it refracting up the silhouette, the shadow, as well?
Yeah, the light that's coming around the mountains refracting just like anything else would.
But
Guys,
shadow cannot be
we're
refracted.
getting the point that Gatebreaker brought up was that refraction always moves downward towards the more dense medium. So when you guys invoke refraction, it should be a limitation on your vision. It should be causing a reduction in observation distance, not an elongation in observation distance.
Exactly.
No,
Good point.
downward light causes things in the distance to appear higher. Everyone knows that.
How?
And
How?
refraction cannot.
Is your real name Ron White by chance?
He sounds like Ron White.
He sounds just like Ron White. I don't mean to
Who's that?
poke fun. He's like a
Who's
famous
that?
comedian. You sound exactly like him.
The horizon past the sectors.
Yes.
So when you're seeing the horizon at the first platform, that is still a black swan. When you see the horizon past the second platform, it's a even better black swan. But both images you just posted demonstrate that your ball earth mathematics is false. Because at 1 foot observer height, the distance to the horizon cannot be further than 1.2 miles.
Okay.
And the first platform is 6.2. And 6.2 is a little bit more than 1.2.
Yes.
Do you
Okay, I
understand?
agree with you. Okay, no, I understand. I know 2 is bigger than 1. I got you. I think I got you. Okay. Here's the question I have for you. What you're saying is you need to include refraction, okay, which you are not, but fine. I'm giving you 2 different pictures, okay? The one on the left is your infamous black swan for flat Earth, and the one on the right, I don't know if you can see those pictures or not. I'll put them in the chat.
Yeah, I'm looking at
It's okay. So why do you think they're
Yeah,
different?
he put them in the. Well, they're in the audience text though.
I'll put them on both places. I don't know.
Both. Okay, all right.
Yeah, I'll put them both places. Why do you think that is the case then?
Why do I think what is the case?
The same place, they look different. One on the left, platforms. The one on the picture on the left. Let's talk about the picture on the left. Okay, there are 2 oil rig platforms. Okay, on that picture, the oil rig on the left oil rig platform, you can see the what you call it stands. Now, if you move to the right picture completely, the oil rig on the left is disappearing bottom up.
Yeah, dude, check this one out. I'm gonna tag you in it. If Solar wants to respond, go ahead. But just very briefly, this is another one. Have you seen this one? I'll just leave it at that. We can talk about it in a bit. But I just wondered if you've seen that one too. Because check out the difference in the height relation. Isn't that incredible? Like wow, you know, like the one on the right. Like anyways, you can see there's like little red lines drawn to where like they don't. And again, same location, same elevation, but different days. And this does say magnification, which but I'm showing it partly for the images. Wondered if you've seen that one too. But go ahead, Solar, if you want.
By the way, if I keep cutting out, it's not my fault. Sorry. By the way, if I keep cutting out, I don't use the app. I use the web version. So The web version of Discord is not that great, I have to say. It
Your
works
sound is
fine.
fine, bro. Your
but
sound is fine.
So I've just got one simple question to ask you. As I explained in the last sort of tirade that I went on, from a 1 foot observer height, your distance to horizon must be no more than 1.22 miles. In your right hand image, it appears like the horizon is at the first platform, which is 6.22 miles. So let's call that 5 times further than your ball Earth should be. And the left hand image, the horizon appears to be behind the second platform, which is 9.2 miles.
Yes.
And your ball Earth horizon should be no more than 1.2. So let's call that 8 times. So in both of these images that we're discussing, why do you think it is the case
That
that
is my
in the one instance it's 5 times further than it should be, and in the second instance it's 8 times further than it should be? Why would you, or how do you reconcile that in both those images, which you seem to think was actually some kind of evidence to support you,
Are you
that the
saying
one
there's no obstruction? Are you saying there's no obstruction in that right-hand image?
I'd never said that. I said, why in both of these images is it magnitudes further than it should be based on your ball Earth mathematics in
Are
the
you
magnitude
saying the
of
Earth's not evolved?
500% or 800%? Why would
I thought
you?
you were going to ask him a simple question. Sorry.
It started simply, but then I think I've overcomplicated.
What do you mean the Earth ain't no globe?
No, it is a good point though. I mean, as well.
Both the images are well beyond what it should be if your ball was a ball with a radius of 3959.
Yeah, the image on the right it has obstruction on both platforms. I don't know why you're saying that you can see all of them.
Well, just
See,
to
you're
Steelman
stuck
his
both
rebuttal,
ways,
he's
left
not
lane.
really addressing. Just to Steelman his rebuttal, sorry, he's not really addressing why there's different amounts that are obscured of the legs on different like that. I think what he's basically just saying is that both of them are still falsification of the globe radius, right? Solar, is that a decent Steelman? So you're not really addressing why that actual the phenomenon directly, but you're rebutting it in terms of it not being, because I mean, if they're trying to make that, the claim
Yes.
that indicates
The objects, 100%. The objects called the oil rigs are there as distance markers. They might as well be street cones. And we know that the one street cone is 6.2 miles. The second street cone is 9.2 miles. Your ball Earth maths says it can be no further than 1.2 miles based on a 1 foot observer. So in the one image to the right, which you think supports you guys, it's 500% further. And in the image to the left, it's 800% further. So I'm asking you, why do you think in both the images, the one is 500% further, and the second image is
It's
800?
not. You're not making sense, man. Because if you analyze those images and you know the dimensions of those oil rigs, you've got about 20 feet of obstruction on the first platform, and like 60, I think, feet of obstruction on the second platform. It fits the
We're not
globe.
talking about
It fits the globe measures just fine.
That's false, because the platforms are street cones, like road cones.
I don't
They're
care how
there
far
as
away they are. You're not addressing the obstruction, dude.
they're distance markers. We're talking about distance to horizon. I don't know how much more simply I can put this. If your next sentence starts with, if you look at the oil
You're not
rig,
addressing it. You're
talking
pretending
about
like there's no obstruction there.
horizon. You're talking about
Some
an
people will
obstruction
never
in the
see
horizon.
the argument you're making, Solar.
No, I've put it
No
as
matter
simply as
how concise and clear you make your argument, some people just won't see it.
No,
That's
he's not
why.
addressing it. He's not addressing the obstruction of the two
I've probably
platforms.
said it. I've
But
probably
even if
said
you
it
did,
many times. It's distance to horizon is the only purpose of that image.
How far is it there? How far
And
is it to that horizon in that second image there? Solar, how far is it to the horizon in that second image?
Yeah, well, I was gonna say solar. Isn't it actually more? Because it's gonna. I mean, the when it's past the second oil rig, you have to add several miles. I mean, that's unknown to even get the exact one, but it's more than 800 times.
It's a waste of time.
Yeah, I'm giving them the benefit of the doubt. And then the
Where is
right
the
hand,
horizon then? Where is the horizon in that second image?
The moon.
So, which one are you? Which one are you talking about, Leflane? Which one?
he's talking about the right hand one where the front oil rig seems slightly occluded.
Yeah.
And he's saying we cannot calculate the distance to that one's horizon, which I'm presuming is pretty close to where that oil rig is.
There's
But I'll
20
give him
feet
that.
missing.
In front of it, though, it does. It would be in front of it because if it's cutting off the bottom, see, that's what like solar. That's what I think is occurring is where like the limit of the ground layer and where it's where the ground and sky meet optically, and that can change on different times. It's all happening over a planar surface. It's all the planar foundation. The planar foundational geometry is always there. Like the one on the left, when you can see further, is just boom, extended plane. But you just get this effect in certain conditions where the ground layer is of a much shorter distance. Like you're not able to see as far on, of the amount of ground due to the conditions, which I think you can get like a bifocal, like kind of lens occurring, effect happening as well, like down near the water and different things like this that can kind of essentially can end up magnifying. And then it can kind of, the reason that horizon looks like it's coming closer, it's all over the planar geometry, but if you're not able to see as far on the ground layer on that day, then where the ground and the sky meet is going to be much closer. And in this case, it looks like it is, in between the observer and that first oil rig, but it still looks like it would only be probably like only because, well, depending on how much of the legs are obscured and all that, probably could be calculated to a degree, but it still doesn't fit the globe geometry.
Yeah,
Still,
and that's
still
why I
beyond
said
the globe.
on the right hand image, because the oil rigs are simply distance markers. The oil rigs are irrelevant. So anyone who wants to talk about the left leg or the right leg or the top right pole or the left, it's irrelevant. It might as well be a street cone with a distance written on the street cone. The only purpose that the oil rigs are in the photo was as a relational point to horizon. But I'll concede that the right hand image, where the horizon appears to be slightly in front of that first oil rig, because there is no other distance marker between the oil rig and the observer, it's very difficult to state exactly where that horizon is presenting. But from a simply logical perspective, it looks like it's closer to that horizon, to that oil rig, than to the observer. And from a distance or observer height of 1.1 feet, it should be no more than 1.2 miles. It certainly doesn't look like it fits that, but there isn't sufficient data in that right photo to indicate that it's not at 3 miles or 4 miles or 5 miles. So I'll concede that the second photo is a bit ambiguous, but it's still further than 1.2 miles, which it should be on both images. And like we stated, and like Gatebreaker stated, refraction bends downward. And anyone who says, like, if I crouch down below my bed, then you should see me floating above my bed, really doesn't have a faculty of thinking, because anything that bends down doesn't go up.
That's a straw man of what refraction does.
Down is the opposite of up.
If
So
we just
light
go by the
bending
sorry.
down, it is not positioning it higher.
If we just go by the words, I see where you're saying, because I had that confusion too, or what I thought it was. Basically, the idea is imagine a setup with zero refraction, and you have like a boat in front of you. Okay, you could put your crosshair on the boat, and you could be sure that that's where the boat is. Say you're focusing on a letter on the boat, like on its names on the side of the boat, and you have it on a letter. If you put your crosshair on it, That's where the boat is with zero refraction. Now, when you turn on light bending down, what happens is now you put your crosshair on. Let's say you're still seeing a boat. You put your crosshair on the boat on a letter. That letter is no longer there. It's no longer where you have your crosshair. And the idea is in the initial setup where there was no refraction, we had a straight line, right? A straight line from the letter on the boat all the way to you. Well, with light bending down, that initial straight line that hit your eye, let's say it's hitting your feet now, but you're still seeing the boat. And now the question is, how could that be? Well, the idea for the globers is I'm gonna try to say it shortly. So you know how light diffuses off of an object in every direction? Okay, so basically what's happening is you have one of those light rays that initially was pointing above your head in the non-refractive environment. That light ray that was pointing above your head, when light starts bending down, that light ray now goes and hits your eye, the one that was initially above your head. And this all sounds just complex and stuff, but it's just if we play with it, we can figure it out. With refraction, we could see around and behind things that normally we wouldn't be able to see in a straight light environment. If you get like a crystal ball and you hold it in front of an object, and if you could see more around behind it than you normally would be able to see sometimes. So that's just the idea. So in their model, light's bending down, and it creates the illusion of things appearing higher than it is. In concave Earth, it's the reverse. In concave Earth, the stars are above you in the sky in the celestial sphere, but from the edges of that celestial sphere, with light bending down, it takes a huge curved path to your eye, and the incident angle that it hits your eye and it registers into your eye makes you point to a star at the horizon and say it's there, but in this theory, that star that you're pointing to is not actually there. The same way that boat's letter shifted upwards due to bending light, in concave Earth, which is, I'll stop speaking here, that light from up above you in the celestial sphere takes a curved path and looks shifted down to you.
Brother, I mean, I understand you're trying to explain this to everybody, but the only reason that light would ever come from a higher position, okay, is if it's wrapping around a globe, because positionally speaking, it would be behind the curve, and refraction would be carrying it around the Earth, allowing it to present where it shouldn't be. But this whole concept of refraction just magically making something higher, it's not true. Anything that's off in the distance, especially further, it's going to be closer to your horizon line than it would have been previously. So this whole claim that's going to be higher is ridiculous because it would be even at a lower angle.
Well, the way
Nice try, though. Nice try, though.
The way I explained it was just based on the Glober's current way of saying it. So they could be wrong, and they've got.
I mean, they are wrong.
Hold on. Well, right. I'm going with that assumption. They could be wrong, and the wording that we're using would be flipped. But in the end, the idea of these bent paths of light taking a non-straight path, it's going to appear where it is not. We all know this, right? You know the fish in the water. You don't aim for the fish. You have to adjust. So that's it.
Yeah. I mean, it's totally. I mean, the only thing that Jesse Path of Light, for example, has brought forth been really useful is demonstrating that in a small scale, that the refracted objects are going to be lower than they started. So on a flat surface, great. That's great for us because you just made buildings dip down. Sorry, bro. Don't need a globe for that.
Yeah. So buildings dipping down, if it's due to refraction, that would be upwards refraction, which makes things.
You can call it whatever you want. The effect is the same.
Well, I mean, bro, I have to use words to talk about this idea, right? You can't just not like any word I use. Can I use a word that you agree with?
Well, I think that in your longer explanation, you confused more people than you helped. That's all I'm saying.
Okay, how about you give it a go?
Actually, I just did it in about 10 seconds. You're welcome.
Thank you very much.
All right, I think we should move on from refraction. It's only been 8 years. Right, Gio? Or whatever, 6 years. So I like the celestial theodolite, baby. Oh, what a great argument.
Yo, dude, what's up? Yo, I saw that Alan talked with Jaren. That was cool, dude. I watched I actually still would I kind of Well, I went to the part where Jaron and him were speaking, so I might, but because I think I'm pretty sure I've seen, like, if the beginning part was more the presentation part, like I've seen that part, you know.
Yeah.
So I did, but I might go back and just double check to see if there was anything in there too. But yeah. So I went to and I did listen to part of it, and that was cool, dude. That was like,
Dude,
I mean,
he was basically taking notes, but like, it's so weird. How could he say like, I don't understand it, and then in the same breath be like, it's just a tangent. Why are you putting the observer where he's not? Like literally all the globy talking points, like he was being coached. It's pretty weird, to be honest. But regardless, we'll see if he comes back.
If he flips back again after the presentation that he just gave and that YouTube channel that I got pulled up for, bad commenting or something. Like if he jumps back again,
he won't, man. That would go off script.
Yeah. Well, I
hope
mean,
he does.
just like imagine that if he flip flops, I'm more like if he flops back again, I'll be like, oh, he's not. But that's really problematic because then I'm only accusing, Globers of being this, but it would be more indicative of a waif, a personality that sort of can sort of like turn on a dime, and make vast sort of cosmological changes in their world just because of, I don't know, like little observations like that. I guess not too little, but
I still haven't heard literally any good rebuttal to the celestial theodolite observations. Like it's not just a coincidence if there's 40 of them. I confirmed.
See, that's denial right there. You're denying that there's been rebuttals. There has been rebuttals.
I said good rebuttal. Listen carefully, left lane.
Well, I guess it's a subjective idea of what's good and what's not good.
Of course.
Okay.
He's just
what's the rebuttal, left lane? What's the left lane? Or what's the left lane rebuttal then to the celestial theodolite?
Yeah. The number one thing is like, why are you taking an angle measurement where there's no observer?
Yeah. See, again, not understanding the argument. That's okay. It's pretty simple, left lane. You look at a mountain peak, you wait for a star to go behind it, you mark down the time, that's your measurement. You go take that time, you put it in Stellarium, you see where that star was, the true position, the geometric position, not the apparent position, the true position, and you see if it matches up to the trigonometry. That's it.
So yeah,
far,
you're eliminating the refractive index from the mountain to the observer, the actual observer, the theodolite at the observation point.
Doesn't the experiment itself do that, left lane?
Yeah.
Like you got to remove the refractive aspect.
That's just the point of the whole experiment.
Yeah.
Why do you turn off the refraction? Turn off the atmosphere on Stellarium to get that.
Dude, even Dr. John, right, PhD Glober, has agreed that yes, it does take away refraction in terms of an argument from the observer to the peak if you're using a star to basically as a measurement. If it gets occluded by the peak, then you know for a fact, doesn't matter if it's being refracted or curving down or anything like that because it disappears. It's a physical object. The mountain peak's physical. The star gets occluded. Boom. Mark down the time. And that's it. And if you look at the graph, I'll post it again. Here, I don't mind. I'll post it again.
No, I've seen the graphs and everything. I don't think it's legitimate. I just don't. And that's just my opinion, but I mean, y'all can continue with it, but I just said why. And it's pretty simple to me, but I mean, y'all can continue with it. I just disagree with it.
Does it bother you, left lane, that basically
wait, Rick, real quick. You just disagree with it. That's all? That's your rebuttal? That's why it's not a good rebuttal.
No,
that's
I've
why
already said why.
I haven't heard a good rebuttal.
I've already said why. See, I've already said why.
It would seem to me that the globe is literally hidden in the refraction then at that point. If you're saying that, where's my refraction? Why aren't you calculating for refraction? This is where your globe lies. It's in that refractive interpretation.
Yep.
Yeah.
That's where the deception sits. Yep.
Such a great observation. What a great concept.
The globe is literally hidden in the refraction then at that point. If you're saying that, oh, where's my refraction? Why aren't you calculating for refraction? This is where your globe lies. It's in that refractive
Exactly.
interpretation.
Yep.
Yeah.
That's where the deception sits. Yep.
Yep. Such a
If you're saying that, oh, where's my refraction? Why aren't you calculating for refraction? This is where your globe lies. It's in that refractive
Exactly.
interpretation.
Yep.
Yeah.
That's where the deception sits. Yep.
Yep.
If you're saying that, oh, where's my refraction? Why aren't you calculating for refraction? This is where your globe lies. It's in that refractive
Exactly.
interpretation.
Yep.
Yeah.
That's where the deception sits. Yep.
Yep. You heard a good
I've
rebuttal.
already said why. See, I've already said why.
It would
Yeah,
seem
that's
to
not a
me
good
that
rebuttal.
the globe is literally hidden in the refraction then at that point. If you're saying that, oh, where's my refraction? Why aren't you calculating for refraction? This is where your globe lies. It's in that refractive
Exactly.
interpretation.
Yep.
Yeah.
That's where the deception sits. Yep.
Yep. Such a great observation. What a great concept.
Does it also like? Oh, go ahead.
I was gonna ask Biasticles, because I don't really. I saw the point that John brought up one time with these two pictures. What is the rebuttal to those?
It's not even.
'Cause I kind of get what they're
analogous,
saying.
though. It's not like, okay. The starlight takes a curved path through our atmosphere. We see the starlight and the peak at the same angle, red. So geometrically, the star is already obstructed by the peak. That makes no sense because when you look at the videos, I have the videos, you can literally just see when the star gets occluded by the mountain peak. 1 minute it's visible, the next it's not. So that tangent, that red line, should match up with the star. It's not two separate locations. They need it to be two separate locations to save the globe. That's why they want refraction to be incorporated again.
Yeah, they're just adding a curved assumptive orange curve there, which is where the globe is.
Yeah,
basically.
that's where the globe is, but they have to say it has to be there because we're on a ball. That's the only rebuttal. Yeah, there's 40 observations now, all confirmed, and different mountain peaks, right? Different occlusions. Like, it's not just a coincidence that it matches up with plane trigonometry.
I understand the assumptive factor of the refraction, but are we saying there's no refraction, like that the mountain couldn't be blocking refracted light, or
it doesn't matter if it's blocking refracted light or not. It's because it's a physical obstruction. Like Dr. Mike made a great example last time, which was basically if you take a tongue depressor, put it in a salt water tank, shine a laser through it, right? And you'll see the laser bending down. It'll bend down to a point where it'll get blocked by that physical tongue depressor, right? Then you can triangulate from where you're observing, right, that laser light. At that time, it gets obstructed, boom, and it goes back to the origin of the light source. And it's a straight line through the refractive. Like, that's why it's the true position of the star that matters, not the apparent.
Has anyone actually done that with the tank and the object?
No, but he brought that up as an analogous example of why it doesn't matter if it's refracted or not, because the occlusion is when the timing that's all that matters is when the timing occurs.
So let me make sure I'm understanding this correct. When you jump into stellarium, you're getting the actual position of the star and then comparing it to where it's being occluded and seeing if there is a difference.
Yeah, the time. So so basically, the farther away you are from the peak, right? The bigger the discrepancy will be like you'll see the discrepancy between globe math and flat math, just to keep it simple. The longer away you are, right? Because the farther away you are, the more the ball would, the more the mountain would have to tilt away from you.
The more the ball would be balling. The ball would be balling.
So when you do that, you can really see the discrepancies in the globe math versus flat math. And the reason why he takes the timing of when a star gets occluded is so important, because then you can remove the argument about refraction between the observer and the peak of the mountain. You can totally remove it. That's why it's very important. And then you can just take where the peak is, because that's what blocked the star. You put your lat long in stellarium right where the peak is. You take that star that was just occluded, you see where its true position is, and it matches up every time. Literally every time. It's not a coincidence anymore. It's not just one observation or 7 observations. It's 40. He's doing more mountain peaks. And then he even lays out all the discrepancies. Like, you can see the difference between the globe math, and it gets way crazier the farther away you are. Earth's flat, bro.
So can I ask some silly questions just to prompt conversation?
Well, and anyone can replicate it as well.
Exactly. Anyone can replicate it.
But yeah, I mean, that is very, I mean, anyone, like, if you could just think of yourself going through that process, like, if you right now, you go outside, you know where a mountain is, you have a stop, or you have your phone or a stopwatch, whatever it is, and you get the timing right when you're zoomed in, right when a star occludes on a mountain. And then you haven't even looked at stellarium yet at all. And you do that, and you just take that time, and then you know your distance to the mountain. You would have to know your distance. So you know what the trigonometry would be in terms of, over a planar surface, the mountain, which on a globe would be like tilting away, but on a planar surface it's just directly up, just like plumb lines are all vertical and so on. So when you know that, you then have your triangles. So you just calculate that angle. You don't have to take the angle with sightings. You just calculate it from the distance, knowing where the mountain is and your distance. And then all you did was take a timing. Then you go to the top of the mountain on the stellarium, and then you at the exact same time, and you check the angle of that star. Think of how like thrilling it would be, like, to actually do that. Because I haven't done that myself, obviously, but like to actually do it like once, twice, 3, 4, and you're getting like it's happening every time. It's like you're getting it right. If that's the results of it, that is amazing. That is really amazing. Like, that's got to be just thrilling to see that. Like, every single time, it's like.
So to be clear, Biascles, when you jump in stellarium, flat would expect it to be at the same position it got occluded at, or am I misunderstanding?
So check it out. Stellarium doesn't know where you were originally. That's what makes it so beautiful. We're basically using a globe.
Can't you put your position in stellarium?
Yeah, you can. So if you take the position from Mike's house, for example, to the peak, you get about 219 or about 217, just about. In stellarium, if you go from Mike's house to the star at that exact same time, it's 204. So it's like two degrees before. Right. But then if you go in stellarium and you put the timing again, but then put the observer at the peak and take off refraction, it'd be 231, and it matches exactly with the flat Earth calculation. Now, if you put on refraction, it goes up to 246. So if you're saying if you're going to invoke refraction to that extent, then the star would be above the mountain. Thus, the timing would be different. The occlusion timing would be different on a globe versus flat. That's what makes it so beautiful.
And you realize this is a prediction, ultimately. Now, I'm not putting that on anyone else. I'm just saying I'm saying that. Like, I'm not trying to say that anyone else is saying that, because I don't want to put words on it. In terms of
it is a prediction.
I know. Okay, well, yeah. I mean, if you want to agree with, yeah. I mean, I'm just saying I don't want to put that on, but in my viewpoint, it absolutely is, because if you're able just to be like hanging out, just chilling, and then the star goes behind the mountain, you just note the time. You could be like, you know what? I predict right now, if I go in stellarium and I look, at the top of this mountain right at this time, that the angle of the star will be, and you'd be able to say it, and then you'd be able to go on. Somebody could go on stellarium, and you just completely predicted it using a planar Earth geometry with the distance and the mountain and the time all lined up with that star. And if you can do that over and over and over, then yeah, that is a prediction.
I'm losing you at the part where you go to the peak. Why would you move to the peak?
Because that's what occluded the star.
Right.
So, like, if you were to use a building that was 50.7 miles away, then you would use the building.
Did you guys? Okay, I kind of
So,
see what
like,
you're saying.
right, because we're trying to remove refraction from the argument. We're not saying refraction doesn't exist. Everyone knows refraction exists. Things change throughout the night and day. Taylor has said that multiple times, have cited papers multiple times, which is why this argument gets so frustrating, because if you have a long distance observation that basically proves that we're on a flat, stationary plane, then they can just say, well, that's just because of refraction, and then put in whatever calculation to make it a globe again. It gets frustrating. So
Did
that's
you
why
guys
Dr.
take the
Mike even.
same? Sorry, I didn't mean to cut you off. Go ahead.
No, what were you gonna ask?
I was gonna ask, did you guys also take the angles from the same position though, from the house?
Yeah, he did all of it in the graph. If you look.
Okay.
Well, but see,
And that's-
technically, see this. Well, go ahead.
I was saying that's why he came to his conclusion about them hiding the globe in refraction. Like, literally, they need refraction to save the globe.
Well,
That was
because for
his
me
conclusion.
the argument would come from, for them, would come from you take it in real life, right? And then in Stellarium, take it from the same spot without refraction on, and see the difference between real life and Stellarium, and then that would tell you how much refraction is happening if it is.
Yeah, no, if you take the observer at Mike's house, right, and do it from the observer to the peak, right, without or with refraction on, it's 219.
Okay, yeah.
Do you see what I'm saying? So, like, when you take it, when you have it, when you have it on, it's 219, right? When you have it off, it's 204 to the star. It's 219 to the star with refraction, and then 204 without refraction. And then if you have to the peak, with refraction or without refraction, then it would be, let me see. Let me pull up the graph. It would be about 231, 232, and then 246 with refraction.
I think I'm gonna have to, when I get home, do it in Stellarium because I need the
Dude,
the
check it
visual, I guess,
yourself,
from the
bro.
position.
Check it yourself, dude. And I have the videos. I'm gonna post them.
Yeah, post those.
What about instead of even like depending on Stellarium though, even though it is always good to relate things to tools like that, but what about going to the top of the mountain peak and actually getting at least as what can be gleaned in terms of an angle to the actual star? Like,
that's what Bredimus wanted to do. He was like, I just want to know. I want to know for sure.
Like IRL, like IRL actually
It just seems like it takes out the appeal to Stellarium, but I think the whole point of the argument is to use, because everybody uses Stellarium anyways because of its accuracy, and
Right.
if the light is hitting the peak at a certain angle, then you can't just say Stellarium's wrong. So like if you're drawing a straight line to the peak, it's a straight line at that angle.
Yep. And again, I haven't heard any good rebuttals. Good rebuttals, subjectively
Yeah.
good rebuttals.
I think this is a beautiful thing that's came about because of this, because I've been saying for a very long time that refraction is bullshit. I mean, they try to invoke terrestrial refraction out of the atmosphere, and if you look on the, you look at all the circumstances for terrestrial refraction, you always have to have two separate mediums. Who the fuck is talking?
Brett? Are you hot mic?
I guess I'm done.
Yeah, no, he was hot mic, and you're good, God rocking. He didn't mean
Oh, all right. Well, I just think it's I've been saying refracting is a load of horse shit all along, and they just want to keep invoking terrestrial refraction in the atmosphere that is one medium. I just am been so adamant that the atmosphere is one medium. Yeah, it could maybe change very slightly, you know what I mean? But it doesn't change like terrestrial refraction when you go through two separate mediums, two completely different types of medium. That's terrestrial refraction. And that's what they try to invoke through the atmosphere, which is one medium. And I've been saying this all along, and I'm just so glad to see this new deal with stellarium and taking this angle from the peak that just shoves refraction right up their ass where it belongs.
Wait, what are you saying terrestrial refraction is?
It's two separate mediums. Look it up.
Why do you say that about terrestrial refraction? Is just the refraction we see on the Earth, and so the celestial is just what we see in the sky.
Terrestrial refraction is two separate mediums, like plastic and water, or something like that. It's not air.
Incorrect.
Okay, show me how. Tell me
because the density at your observation level and the density at the peak level is a gradient. So it's not the same medium at the instrument as it is at the peak, and that is a continuous gradient. So
I think you're full of shit. So I'm not even going to talk to you about it. You can shove it up your ass, bro. I'm done with you.
Okay. I'll just hang all my measurements for decades. So I'll just put that off to the side. And 200 and every industrialized country in the world and 200 years of science. Yeah, you're right. Everybody else is wrong.
Thank you very much.
All right, you guys.
I just can't stand these globers. I just can't stand them with their fucking refraction. It's a bunch of bullshit.
What experience do you have in actual measurement with proper instruments?
Listen, I got no time for you, bro. I don't even have one more second in my life to speak to you. Sorry. Beat it.
I'll take that answer is none.
Okay. What do you think about the celestial theodolite concept, Shoebill?
In concept, it's great. In execution, he's dealing with a flat Earth premise going into it. Like the vertical at the peak is the same as the vertical at the house. Yet he's 28 nautical miles apart, or 28 arc minutes apart in great circle length. And so, yeah, there's a definite issue there.
Wait.
Well, what is the issue? Yeah, what is the issue?
Wait
Do
on.
you want to go for
vertical angle? Yeah, vertical at the peak and vertical at the house are different by 28 arc minutes.
Well, is that you assuming that? Because he's just measuring the distance to the mountain, measuring the time of the star occlusion, calculating that triangle, and then going to the mountain and getting that angle to the star, and it all lines up, making a triangle with a right angle triangle, planar, triangle.
That's what I just said. The right angle triangle, which is assuming that you're building a triangle, but you've got two different vertices. The only angle that matters is at the house. The vertical angle by calculation from the peak, since there's no observer there, then don't calculate an observed angle from that which nobody will be observing. All the observations take place at the house.
Stellarium, bro. So you're saying stellarium? You can't use stellarium?
I didn't say that.
Brutal.
I say that it's using stellarium.
Because it matches with stellarium. Like when you go to the mountain peak and do the angle of the star, that matches with the time you take down on the ground, along with the distance of a planar triangle.
Well, like I said,
are you throwing out stellarium, Shoebill?
Absolutely not. I'm only using a singular. There's only one point of reference: the instrument.
So if you go to the base of the mountain,
that part of it, I actually kind of agree with, because like it would be good to go onto the mountain peak physically and get readings and measurements there, in addition to looking at stellarium. So I do hear you, at least. Like I agree with part of what you're saying with that part of it, but it doesn't really address all the other things that have been laid out.
If he goes to the base of the mountain, it's the same outcome. What would you say, Shoebill? If he shot the 2 degrees from the base?
Well, if he goes to the mountain, then he's going to key in the coordinate of the mountaintop, and then he's going to retrieve the angles from The mountaintop
No,
from
the
sterlium.
base, the base,
from sterlium.
the base, not the peak of the mountain. If you just went to the base of the mountain and he shot and he got the same results, would you?
Well, it would be a
What
different
would you
angle.
say there?
Yeah, he's still 28 arc minutes of great circle distance from the house.
But you see how that is what's
Yeah,
in
but what would you
question,
say?
Bill? Hold on. Well, that's a different angle, though. Pure. That's you couldn't see the star. The point is using the star, right? That's the point of the celestial theodolite concept, because you're taking the true position of the star according to stellarium. So we're not throwing out stellarium, right? We're not going to throw that out. And we're just taking when the star gets occluded by the mountain, marking down the time, seeing if it matches up.
And the observation of the star occluding behind the mountain is an observation through atmosphere. Therefore, refraction is always present because he's timing it by the observation of the star while looking at it through atmosphere.
Okay, so what do you say when we turn off atmospheric refraction to see the true position of the star, not the apparent, that it matches with plane geometry?
Again, you're talking, these tens of arc minutes, and they're tens of arc minutes apart. So I've been doing it for decades with stars and proper theodolites, and the science of that is clear. The celestial navigation of that is clear. So yeah,
Science is
the
clear.
in concept it's right, but his execution is flawed.
It's because it doesn't
Can
match
I
the
ask a
globe.
question?
It's because
Well,
it
wait a
doesn't
minute.
match
So
the globe.
Shoebill. Well, yeah. So if some other people want to get in, hold on one moment though. Like, Kool-Aid wants to get in, but Shoebills. But the thing is, if you went out and did these observations though, with the star occluding with the mountain, and then you kept getting a planar measurement, don't you think that if you just did that yourself, like let's say you chose to, you went out and you did 100 of these yourself, or you traveled around, whatever it was, and you actually did this. Let's say for some reason you decided to. Wouldn't that contradict perhaps some of your other understandings on things if those were the results you were getting, or do you have a rebuttal as to why you would get those results on a globe?
Well, I'm not clear on his measurement of the angle to the top of the mountain. First, there was this using his David White, and then I understand he got a different instrument and measured it again and got two different values.
But like, what is the accuracy of the instrumentation? Like, if you can draw a triangle in the sky with the distance from a mountain and the occlusion of the star by the peak, your theodolite is always going to be off. Like, that is a way more accurate measurement, right?
Well, yes,
Or am I
and
wrong in thinking?
when I have done it, and granted, I didn't work at the 2-degree level. I was working at 13 degrees, and the 240 arc seconds of refraction, as calculated, matched the geometric angle and plus refraction equaled my measurement for about 3 arc seconds. Now I have
So
proper.
you've done this celestial theodolite
Oh
principle.
yeah,
You've
well, not
performed
this.
it.
I've
Okay.
I've used my real theodolite to a real star, extracted from the ephemeris the geometric, and applied the refraction, and that equaled my measurement.
Why would you use
3
a
arc
subpar
seconds.
theodolite? Like, right, we've just described a technique that's far more accurate than your tool, and you
Well,
want to
I'm
go back to your
saying
tool. Is it? It's just comfort zone, right? Like, that's what you're comfortable with.
no. I'm saying both those tools returned a coherent difference of refraction by measurement.
Well, you did 13 degrees up in the sky, and it's my kind of what I'm listening to broadly is like you need 5 degrees or lower, really.
I understand that. I caveated by saying I have not dealt with 2 degrees.
All right, I need to jump in for 1 second and just let you know, Shoebill, that using your theodolite and pointing it at a star, I consider tool abuse. If you call yourself a surveyor and you're using your theodolite to look at the stars, you're a retard. Thank you.
Okay, the instrument I'm using is called the astronomic geodetic theodolite, specifically designed to deal with the elevation angle and azimuth angle to stars and terrestrial objects in the same setting.
So that's a purpose-built tool to look up Theodolite, to look up this. What is the application professionally for
Can
that
you
sort of thing?
give me a model number of that Theodolite, please?
Wild T3 and a wild T2.
What's the functional industrial purpose of that Theodolite?
Thank you,
Geodetic
Shubin.
surveying.
Just geodetic surveying, eh?
Well, geodetic and astronomic geodesy are
Okay.
in one.
So you're not like laying out what a building footprint should be, or you're not sort of doing any topographical analysis with
Yeah,
it. Like this thing is purpose-built for sky stuff. I'm just trying to work out what's the actual like professional application of this sort of stuff.
You can use a T2 to lay out a building, and you can use a T2 for geodetic astronomy, and which is celestial navigation, which is just like 100 times more accurate than a sextant. And you can use it to lay out a building, but you can't use a David White construction transit to observe stars.
He didn't use
properly.
it to observe stars. Hold on, that's not. Hold on. He didn't use it to observe stars. Why are you strawmanning it?
No, he observed it to observe. He used it to observe a mountain 32 miles away.
A mountain peak, right? So why'd you say star?
Because you do both, and with a
No, he
David
didn't.
White.
He used a telescope to look at the star and watch the star get occluded by the mountain.
Hell, then why didn't he use his telescope? Is just a telescope, and on his transit and Theodolite, you still have a telescope. They're not that different.
Bro, why are you strawmanning the argument?
Yeah, because no, hang on, Beasticles, because all these globers think that the celestial Theodolite is an actual tool.
I know, it's hilarious.
it's a procedure.
Well, but what you're saying though is you're just saying if you used a Theodolite, you could use it as the scope for observing the star and take an angle with it if you wanted. You're saying, is that what you're saying?
Absolutely true.
Right. Okay. Well, I agree. Although that's not necessarily what is being put forth, because it's not really about that. It's not about shooting from the observer on the ground to the peak of the mountain with anything. That part is really just observing the timing of the star, because when that's occluded, that's going to be a straight line distance when you can no longer see anything, when that star is occluded.
Can I ask a question now? I've been trying to get in a minute. I apologize. I
Oh,
got
yeah,
here
you
a
were.
little
Go ahead,
late.
yeah.
I got here a little late. You guys are discussing this triangle. Could somebody walk me through where the 3 points of this triangle are located? Thanks.
Sure. Let me give you some PDFs here too, just so you can see it.
No, I can do cell nav. I've done it to save my life.
No, it's not
just
that.
where
It's
are-
for the specific thing that we're talking about. It's called the celestial Theodolite concept.
Yeah,
Cool.
and you probably think it's a tool that you put in your hand, Beasticles.
No. I understand it's a math thing, and you said you draw a right angle triangle with it.
Well, okay.
Just where are the 3 points?
All right. So
Okay,
Kool-Aid, just to give you. Well, okay. Well, go ahead.
I'm just like
No, go ahead, Gio. Go ahead.
I was thinking of your name. I was thinking, do people ever say like beast tickles? So we could get some beast tickles, like tickling a beast. That's funny. Along with Beasticles and Beasticles, all the
classics.
All the classics. But I've never thought of beast tickles before. No, but you're good at laying it out. Do you want to? Okay. So Kool-Aid, this is a very complex thing that's been unfolding for quite some time. So there's a lot to this. Well, so we were kind of deep in some of the specifics of it. It's fair you may want like an overview. It's always good to hear that as well.
Simple,
maybe other people who maybe haven't heard it. So yeah.
It looks to me on page 5 of your PDF, the 3 spots are: one is the location you're actually taking it from. You were talking about some guy's house. The second point is the tip of the peak, and the third point is a theoretical place at the base of the peak on the same elevation.
That's just the elevate. That's just the So basically, it's just plane trig, right? So you have a prediction, right? So you have a plane trigonometry, and then you have like the globe geometry, right?
Right.
So there's 2 predictions.
I'm just asking where the third spot is. So one
third
is
spot's the star.
observer.
Well, dude, how about beast? How about just give a just a few minute like run over of it, and then
Kool-Aid. Let me explain it to you, please.
Okay.
Just real quick. Just take a seat. All right. So you're basically just making a prediction, right? So you're making two predictions, one for the globe, one for flat Earth, one using plane trig, one using spherical trig.
Right.
So there.
Okay.
Right. So
You
that. So
can
there's a
skip all this.
concept.
Just get to the math.
Well, I'm trying to lay out.
I heard all this.
Alright.
I've read it. I've read your PDF. Go ahead.
Okay, so if you read it, you should understand it. Why you keep interrupting me?
Because, all right, go ahead.
Okay. So essentially, what you're doing in order to confirm which measurement is or which prediction is actually going to be accurate, you're using a telescope. You're looking at the peak of a mountain. You're waiting for a star to get occluded by said peak of the mountain. You take that timing of when the star was actually occluded by that mountain. You take that timing, you put it in stellarium at the coordinates of the peak of the mountain. See what star was actually occluded. If you take off celestial refraction, right, atmospheric refraction, to get the true position of the star, not the apparent, it matches with the plane trig every time.
Okay. So is there a right angle triangle in your plane trig?
Yes.
Yeah, the base of the mountain, the distance from the base of that mountain to the observer, and then from the observer to the peak of the mountain where the star is being occluded. And then the height of the mountain is the last part. Yeah, the altitude of the mountain.
Hold on. Your triangle had 4 points. So there should only be 3 points, right? We have the top of the mountain, the base of the mountain, and the observer.
Yeah.
No, I said 3. That's what I said, yeah.
There's a predicted... yeah, what about it?
Yeah. Okay, then where does the star's location come in? And
so you're taking the peak of the mountain, right? You have a predicted angle from the observer to the peak just using plane trig, right? You get the height of the mountain, the elevation of the mountain, the distance between you and the observer. That's your opposite and your adjacent. And then you got your hypotenuse. That's calculated to 2 degrees 31 arc minutes, right? Then you take when a star gets occluded by the peak of the mountain, when you can see a star.
That's 2 degrees 31 arc minutes. I thought Larry had a much shorter distance. Okay, so that's 100. That's 180 nautical miles. Okay, I'm following. Go ahead.
Yeah, and then if you see, there's a graph to the right. I wish I had the spreadsheet that Alan has, but there's a spreadsheet that does the globe slant. So basically, according to the globe, it would basically be 2 degrees 19 with refraction added in. 2 degrees 17 without it.
So
see if that matches up.
2 degrees 19 is about 180 nautical miles away. Is that what you're trying to say?
No.
It should be, the mountain should be 180 nautical miles away.
No, that's not what I'm trying to say.
Okay, then what is this 2 degree 19?
Oh, the mountain is 6,000 feet higher than the house. So the vertical angle to the mountain being 2 degrees and 19 is the geometric, and 2 degrees 30 or whatever is larger with the refraction.
Okay, so for all of this, we're still only measuring the mountain. Where does the star come into this?
You're looking at the mountain peak with your telescope. You're waiting for stars to go behind the peak of the mountain. You can see the star. You can see it. You can see it. Then you don't see it. It gets secluded by the peak of the mountain. You mark down the exact time. Then you take that exact time. You go to stellarium. Right? You go to stellarium. You put in your coordinates of the peak of the mountain. And then you find the star that was just occluded. You look at the star. You take another elevation angle. Right. You take another elevation angle to that star. Right. The true position of the star.
So now we're making a second triangle, right? This
Correct.
one
Yes.
has nothing to do with the first triangle. We've forgotten about the first triangle. It's no longer useful to us. Okay. Talk to me about this new triangle. Where are the three?
it
fractal,
is
dude.
useful.
It's just fractal. It's one within another because you start with the mountain one, but of course, the star is beyond the mountain, so that's going to be further. So you're going to create a larger. You have a smaller triangle within a larger one. That's why it's fractal.
Okay. So we're using Stellarium, so we're doing instant teleportation. So now we're taking this observation from 58 nautical miles away, something like that, and at 6,000 feet elevation change. We're expecting that the altitude of this star will be radically different. Now, what am I measuring this star to when I'm standing on the peak of this mountain?
Stellarium.
Right, using Stellarium.
Which uses nautical almanac.
Right. What am I doing with the star?
You're looking at the elevation angle from the peak of the mountain to the star at that exact same time that you saw the star get occluded by the mountain peak.
Okay. And what does that tell me?
Well, it tells you 246 with atmospheric refraction turned on and 231 with atmospheric refraction turned off.
Okay.
So what does that tell you? What do you think that means?
That means refraction plays a role in all long distance observations. I hope this isn't news to anyone in this room.
Can I make a comment on that?
Hold on. The problem is your triangle doesn't include the star. As soon as your triangle includes the star, you no longer can make a right angle triangle because you don't have all three positions. The problem with this test is you don't have a triangle that includes the star.
I don't know how you're getting that. I just told you the exact process. You're at the peak of the mountain, all right? You have an elevation angle to the star. Guess what? It matches with the flat Earth prediction.
Okay. Go ahead and talk amongst yourselves. Let me draw it out, and I'll be right back.
Well, no, here I have it. Here, are you looking in the chat right now, Kool-Aid? Are you looking in the chat?
Yep.
All right. Here, I just went and got it.
Thank you, Gio. That's what I was looking for.
Yeah. So.
Right.
So first, see if the globe Earth prediction.
That's super wrong. That is way wrong. Who the hell drew this diagram?
Oh yeah, why is it wrong?
Because
you can also hold on. You can also analyze this one.
No,
go ahead.
No. Okay. Do you want me to tell you what's wrong with it? That one's got the same problem, even worse.
It's all good, dude. We got time. Go ahead. You got the mic. Yeah, go ahead if you want to respond to it.
Yeah.
Why is it wrong?
Just went and grabbed a few of these images since we were talking about some of the math and stuff. So I just wanted to, since this is what you guys are discussing, so just give something to go off. Go ahead.
You said it's wrong pretty quickly. Why?
Because you're not taking into account dip angle.
What?
Dip angle.
Dip angle? We're not on the
Go
ship,
ahead.
bro.
What's that?
You're not taking into account
angle?
dip angle. You're using level as if you were at sea level when you're on the top of a mountain. Cheers. That's really funny. You guys keep doing that.
Yeah, this guy, I'm done with this guy. I had a drink of the Kool-Aid and it tastes shitty, dude. Tastes
it's
really
okay.
bad.
What's the dip angle?
Yeah, what's the dip angle, dude? What? You condescending fella?
Yeah, it's not necessary in Stellarium, sir. And that's where the measurement from the mountain peak is taken, is from Stellarium. You're choosing to strawman this process.
No.
You are.
I'm using celestial navigation as I have used.
This is
my own life.
Hang on, guy.
You are.
This
All right, you
is
guys, hold on for a second. Rob, hold on. Yeah, you guys got to chill. Hold on, Rob. You can go next, dude, and you get in. Let's just chill for a second. Just hold on. Let's let Taylor go. You guys, she's been trying to get in. Please, guys, let's try to keep our points
I
concise.
want to know what the dip angle is first.
Sure. The dip angle is the correction you use in celestial navigation to reset your viewer height to sea level. It counts for the fact that as you're up higher, you can see further, and you have to look down to see the horizon.
Yeah, we're not talking about celestial
So why would that
navigation.
make this hold on? So would that change the star's actual position in the almanac?
No.
Well, that's
So
all
the
that they're using.
The position in the almanac is its GP, right?
Good catch, Taylor.
That the position is the GP, and that is based on the astronomical center of the planet.
So is this a refraction issue?
No, this is.
He's saying dip angle because we're above sea level. He thinks
Sorry,
it's
go
like
ahead.
the height above.
Go ahead.
Is that right?
You explain my argument. Go ahead.
Well, I'm trying to get my head around your argument, so excuse me for just asking a couple of questions about the way you're orientating it. You've come in with a chip on your shoulder, whatever the case may be, man. But you're more than welcome to sort of articulate it. What's this dip angle? Why is it necessary for taking sort of angled measurements to stars in the sky or mountain peaks?
Yeah, I don't think it actually has any relevance to this conversation.
None. We're not doing navigation.
Yeah, these are 50-kilometer distances to a mountain peak, right? What is the altitude of Dr. Michael's?
I think it's like 2,200 something feet, if I remember. Let me look at the PDF.
So he's pretty high above sea level.
2,074 meters.
But that's accounted for, isn't it? Within when he does the yeah. So what's this dip angle? What's this?
Yeah, well,
it's called a Hail Mary. You know, like when you don't have anything else and you have to go for a Hail Mary.
Well, I don't know if he was going to respond on that. I mean, I mean, real quick, Shubil, see that one you just posted, Shubil? See, that's the thing, dude. If you could go out and measure that, like let people know, or like if you can go out and do that, you know, because I see what you did there with the red lines. I see what you
because vertical is radial to the planet. So in that diagram where the vertical of the mountain and the vertical of the house were the same, that's a problem.
They weren't.
For the globe.
They were at different elevations.
I mean, the dip angle calculation has to do with how high you are above the surface.
Well, we're dealing with zenith angles and angles from horizontal. We're not using an ocean horizon, so I recoil at the use of dip.
I agree.
Hold on.
I was just explaining what it is.
Is there any chance I could actually back that up, or would you guys like to just continue?
We're not talking about celestial navigation, bro.
I would like to know.
But we're
yeah,
not.
why
Keep
is
in
the
mind.
dip angle not
Keep in
relevant?
mind, we're not using the ocean horizon.
Cool. Let me know if you guys want me to actually back up anything.
All right. Well, as long as
I want to see if this guy can swim. Yeah.
Let's just we can keep our cool. Everyone can have their mic time. So yeah, dude, if you want to come back in, yeah. Wolves, like you brought it up. Shubil posted that image. They were still mentioning it. We've been waiting to see if you want to come back. But go ahead. You got the mic if you want to describe what you mean. Go ahead.
All right. So the angle that you're measuring is from the horizon to the star. That's literally you've been referring to as the elevation angle. And when you're standing at the top of a mountain, no doubt you're going to have a different elevation angle, as described in the very simple article I just posted. Dip angle is the problem you're facing.
But they're not using the horizon. They're using horizontal.
No, they're using the horizon.
They are not.
Said it 3 times.
Yeah, no, but they are not.
Then he said it wrong.
That's why I brought that up. They're not using an ocean horizon. They're not using a visible horizon. They're using horizontal, which is derived from, the level vial of vertical.
Okay, so you're not even taking an observation.
Dude, he's on your globe side, bro.
You can call them zenith angles. You might as well just call them zenith angles. Just add, subtract them from 90. Yeah, it's a horizontal. Okay. It's a vertical angle from horizontal. Fundamentally the same as a zenith angle.
I mean,
all right. I don't understand what the hell you're doing. You guys carry on. It doesn't make any damn sense to me.
Yeah.
Well, I mean, that's why, like, when Beast was gonna kind of lay it out, and then there was a lot of like interruptions.
He was trying to get a gotcha before I could even explain it to him. It's pretty annoying.
That's why we wanted to lay it out for you. Well, we were gonna like lay out the red carpet for you and let him explain it, and then you could have. But yeah, I don't know. It kind of went a different way. All right.
But I'm sorry. I was looking at the diagrams that he posted to me, which show exactly what I've said multiple times, with where your triangle doesn't involve the star. But cheers.
Okay, so you're saying a dip angle you're saying you would need a dip angle if you're going from the angle to the top of the mountain, so you would not agree with what Stellarium gives for that angle? And you would calculate it in some other way based on something having to do with the horizon, which is not what this is involved with?
No, when it was explained to me, the second, because you're trying to make 2 triangles, right? Or a fractal triangle, as you called it. And
well, it only is if you take the GP of the star. If you took the GP of the star over a planar surface, it would be, yeah. If you added that last point, yeah.
Oh, so you now, okay, so the 3 points, back to my original question when I was trying to figure out how this thing works. Where are the 3 points of the triangle we're making?
Dude, base of the mountain, peak, and then where the observer is. That's the first triangle.
That
then
triangle does not include the star.
Right.
Where are the 3 points that include the star?
Well, the
The
star
peak of the
lines up at
mountain.
the peak of the mountain. So
Yeah, the peak of the mountain and the level baseline from the peak of the mountain to the star, the elevation angle to the star. Look at the picture. Do you see the picture?
So in that picture,
Uh-huh.
if I was to draw a triangle, I would draw a line from the star straight down to the level that was established at Vantage 1, correct? Why would I draw it to that level? Why wouldn't I go all the way down to the
because
same?
level is horizontal, so it's all horizontal and level, and this shows that the plumb lines are also vertical.
Well, if you're just taking a tangent, why don't I just take 1 foot from the star and say it works? You need that triangle to have the third point on the same baseline that you're originally looking at it from. You do it on that first triangle, you draw the line. That line should be all the way under the star, shouldn't it?
Do you know how do you know why we're able to go to the peak? Do you know the second part of this that I was trying to explain to you?
Well, this is the thing, dude. Like
do you see how you're refusing to put the third point on the triangle?
I don't even think he wants to understand. I'm done. I don't even want to.
No, yeah, dude. He's coming in hardcore condescending. Like, do you just come in here to dunk on people or something, dude? Like, Biasicles was trying to sort of describe to you what this, what would you call it, tool is, the celestial theodolite that's been sort of proposed as a method of measuring. Mm-hmm. And you cut him off, like, I don't know, maybe like a paragraph in, presuming that we don't know how to draw triangles or something.
He was reading
so
the
I think it would
PDF.
Be best,
he was reading the
I think
PDF
it'd be best for you.
Mm-hmm.
I think it'd be best for you to just sort of maybe actually hear out the entire thing before you start shitting things like, oh, you haven't done triangles right. Because I think you've had to retract that so far. So maybe it'd just be best if you just chill out for a sec, bro.
I'm standing behind. You guys are afraid to put the third point on your triangle.
We're afraid.
So the top of the peak, the base of the mountain. Okay. Yeah, the base of the mountain, right? Like inside the mountain, right below the peak, the top of the peak, and where the observer is placed. What point are you looking for?
That triangle doesn't involve the star. Involve the star.
So that's the second part of the operation, which you didn't take any time to listen to. You started picking up
the star in that triangle.
Now you're gonna cut him off.
No, dude, we're not here to take demands from you, bro.
Gio, can we move on from this guy? He's obviously not listening and not having a good faith conversation.
You're unwilling to draw that triangle.
Yeah, we're unwilling to
deal with why.
Yeah.
I know why.
He lost this one.
Okay, so I know why you're unwilling to do that. Okay,
I don't know. No one really seemed interested in talking to you. Unless someone else wants to.
They're not measuring the angle of the star. They're measuring when the star gets occulted.
Right.
What's the problem with that?
The problem is
and then they go into stellarium. So the second triangle.
Gio, really? Can I get like 30 seconds to answer? Can I get
Taylor?
A little help,
you can go back and forth with this guy if you want, Taylor. Go ahead. Go ahead, Kool-Aid.
So if you're going to build a triangle that involves the star has to be one of the 3 points of the triangle. The reason that this doesn't work is because if you draw that down and give us the GP of that star, it will not work for you. I understand this.
So they're not actually trying to measure where the star's at.
Right. They don't want to put
measuring. They're actually not measuring anything. They're just counting when the star is occulted using like a clock.
And they're occulting it behind the horizon. That's what you
the peak of the mountain.
No,
dude. Peak of the mountain. Including the star, bro.
They're really not measuring. Like you can do this just with a timer.
It's amazing that the peak of the mountain isn't on the horizon.
Dude, you don't even listen. You couldn't even steal my
That's new.
About, dude.
It's at least 2 degrees above the horizon.
Seriously.
He's not listening. Can we move on from this guy, Gio, please?
He's choosing not to understand. He's choosing to ignore what we want to put forward to him.
You guys are fun.
Catch you later, bro.
Kool-Aid, I just want to tell you,
I'm
They're
sorry,
just
your
literally
friends will not
counting.
let you talk. They
But
don't think you're worthy of the time. You can try though.
I was just saying that they're just counting whenever the star is occulted. Okay? And then that's pretty much it. And then they're going to use that angle of the star measurement to know the height of the mountain.
Right. So the triangle has nothing to do with the star because they can't.
Oh my god, bro.
Okay. Well, then just forget about the triangle.
Right.
They're just
Okay. So now we're no longer doing trigonometry if we no longer have a triangle, right?
Well, they're trying to get the elevation of the mountain, right? By seeing when the star is occulted by it.
Yeah. It's almost like the star isn't in the triangle.
So what?
Christ, dude. Can we move on from this guy? You must
Yeah,
be
I
fun
think
at
so.
parties, bro.
I
It doesn't matter if the star's not in the triangle. Nobody claimed it really was.
I
Like, the
apologize for destroying your gotcha. Go back to patting yourself on the back.
See you later, bro. Gotcha.
Hey, and while you're at it, go fuck yourself.
Yeah.
Yeah, you should have taken it half an hour ago, bro.
Yeah, dude. Go to Gem.
I apologize.
It doesn't matter if the star is not in the triangle. Nobody claimed it really was.
I
Like,
apologize for destroying your gotcha. Go back to patting yourself on the back.
See you later, bro. Gotcha.
Hey, and while you're at it, go fuck yourself.
Yeah. Dude.
Yeah, you should have
Really came
taken
here for.
it half an hour ago, bro.
Yeah, dude. Go to Gem Panda or something. This is where they get off in this sadist-like behavior.
And I wanted to make a comment earlier on the refraction thing, like about turning off the refraction, because in Stellarium, they actually use for the refraction calculation the Young's air mass and refraction that was done in 1994. This assumes standard conditions. Please take note of that. It assumes 15 degrees Celsius and 1013 mbar. So that is like not reality because you're not always going to have those same, temperature conditions, etc. Like that's just assuming one particular temperature. Now, if you were to go in there and enter the different temperatures of whatever layers that you're studying, like that would be relevant. But if you don't have these particular pressure and temperature conditions, these standard pressure and temperature conditions, quote unquote, then you might as well turn it off because it's not going to be accurate if you're worried about refraction. So there's no need to have that on, period, because like you're not going to have those same temperatures most likely. Whew. So I just want to mention that.
That's a great point. I wonder how advanced Stellarium can get.
Yeah, let me look up the model it's actually based off of. Stellarium, it's like VSOP something, if I remember correctly.
So you should have that feature turned off in Stellarium, unless you're sure that it's matching the exact temperature and pressure conditions, which you don't know.
Yeah,
Most likely it's not.
Stellarium uses the VSOP 87.
That's where they sneak the globe in.
Yeah.
It's the it's the globe lubrication.
Did you just say, Taylor, that you should turn off refraction unless you know the gradient?
Yep.
And by the way, a good estimate for the pressure at his house is about 748 millibars. That's approximate, admitted, but it's going to be in the neighborhood of 750 millibars.
Well, they're using 1013.
I know, and that's why the formulae is laid out with an example at 1013, and you key and the formulae is laid out with symbolic, so you can enter the correct variable in that formula.
How would you know? And how would you know the pressure and temperature? Is it just of your local area?
Well, that could be measured at the instrument, which is easily done. My smartphone is only off a couple of millibar, so it's a pretty good estimate. And temperature, I carry thermometers, so I measure temperature and pressure. And he did not.
My husband would be jealous because he tries to carry all kind of stuff, but I don't think he has a thermometer.
And when I calculate, when I use estimated calculated refraction using a measured pressure and a measured temperature to a star, I get 240 arc seconds of refraction, and that equals measurement and geometric ephemeris.
I wanted to ask you, would you need to know the temperature and pressure like levels at higher atmospheres if we're doing like celestial diffraction instead of terrestrial?
And that goes to the standard atmosphere. When dealing with astronomic, you're going through the entire gradient. So the troposphere is a small component, and the other 200 miles of atmosphere is dominant and not changing much. I know when we're flying around at 40,000 feet in our mapping aircraft, the temperature at 40,000 feet is almost always minus 52. I mean,
But what
and
about like the thermosphere and then it gets colder in the atmosphere? Like that wouldn't do nothing?
that's still a minor component to refraction.
Okay. And then also, I guess that would be taken into account whenever they did those the almanac measurements, because that's like their actual position, you know?
Well, the almanacs give geometric, and then you apply your environmentals, and you get the modeled formula, which has been determined at the highest level of science for the past couple hundred years
How did the almanac get the actual position? Like, did they take into account?
by measuring with precision instruments at all the major observatories in all the major countries throughout the whole world.
Okay. So like we can basically say that they're accounting for the atmospheric refraction, the high levels, by their almanac measurements. Like their actual position based on the almanac would be accounting for like the standard gradients within the atmosphere.
Sorry.
They return the declination and sidereal hour angle of the star. Everything else is a static geometry to the shape of the Earth, and then the observation through the atmosphere. That is a bit of a variable, but it's not some wild bullwhip of unknown.
Okay, wait. Here's something. Atmospheric refraction was added to stellarium in 2011. So how did they incorporate it before that?
Well, it sounds like they didn't.
Exactly.
Yeah, so they didn't have an atmospheric correction option in their software. That doesn't mean. No.
So wait, Shubil, I want to finish this line of questioning real quick because I want to know. So you're saying the only thing that would really mess it up in terms of refraction is your local temperature and pressure because everything else is kind of accounted for in the almanac?
It's accounted for in the model formula for refraction.
So what's the model formula for celestial? Is it much longer? Like does it account for like higher atmosphere gradients too?
Yes, because that's why you enter your local station pressure. Now I use the SMARTS formula with the along with the low elevation angle coefficients, and I get within a couple of arc seconds.
So basically, the almanac, they already accounted for the standard gradients whenever they measured.
No, they did
the
not.
position.
No, they gave geometric, and it because they don't know your conditions, so they give the geometric, and the geometric they give the geometric in the geometric
your conditions matter.
Well, the geometric in the almanac is the GP of the sun, or the GP of the celestial body, based on sidereal hour angle and declination. After that, you have to use the spherical geometry of astronomy.
Okay, so basically, just to sum it up, like we only need to really put in our pressure and temperature of our local area, and then everything else is dealt with. Is that what you're saying?
When you apply the formula, or if you're relying on the software to do the formula. So in the some of the softwares I use, they have there's an entry for station pressure, station temperature, and in my spreadsheets, I take those formulae and incorporate it into my spreadsheet, and I make my measurement. I get the sidereal hour angle, I get the declination, and I calculate the vertical angle geometric, and then I calculate the refraction, and then I make the measurement, and I find that I'm and a precision time down to about a tenth of a time, 1 second of time, and I find that I'm within a few arc seconds of complete coherence.
For celestial
Yes.
measurements? So what is the difference in the calculations for celestial versus terrestrial? If we want to calculate refraction.
In terrestrial, you're dealing with very small vertical angles, and both the target and observer are in the troposphere, so that you just use a much more simple coefficient of refraction with a temperature gradient, and there are formulae for that. But they are two distinct different formulae because both the target and the observer are in the same atmosphere for a minor gradient. 6,000 feet is not that big a difference.
So
but it is
celestial refraction
but it
calculation.
is modeled and accounted for. And
Mhm.
to astronomic, you're going through hundreds of miles of atmosphere straight off, beyond the troposphere, beyond the tropopause, and into the ionosphere. Yeah, that is a not an overly sophisticated formula, but it is published. The SMARTS formula with the low elevation coefficients are available, and I have tested it with my measurement against the ephemerides, and I get again very high compliance. Now I caveated, the lowest I've ever addressed that is in the 13-degree range because
So the celestial is can you maybe share with me those calculations? And what do you think about the Young's air calculation from 1994? Do you think that one's suitable?
I have not examined that one. I suspect it returns nearly identical to the SMARTS formula.
Okay, yeah. Can you share with me the formulas they use for
Yes,
celestial
I
and
can.
terrestrial? I can try to find them, but
And I posted a measurement that I made.
okay. Yeah, so you would agree that stellarium's general pressure and temperature calculation would not be suitable because that you're not in those pressure and temperature calculation standards most likely.
I do not know if you can enter meteorological values into stellarium.
I know you can enter temperature and pressure. I guess that's just local though.
Oh, absolutely. Yeah, if you're going to enter a temperature and pressure, it would be at the telescope. Yes. So if you take the due diligence to add measured values into stellarium, they're running the same formulae that you reference, that I reference, and they're not going to be significantly different.
Mm-hmm. And we don't have to worry about the higher atmosphere because it's going to already account for that in the calculation.
That is the second order polynomial structure of the formulae. Yeah.
Okay, cool. I'll let Dr. Mike know that he can probably do that in stellarium. But yeah, generally you would turn off that feature if it's just one temperature and pressure. That wouldn't be right. But yeah, I have read that you would be able to enter that into there.
Literally says in this article I just found that the right side, and in reality, we are actually seeing light originally coming from below the ground. They literally need it. Yeah, dude, read that article.
Yeah, just like the sun geometrically at sunset, geometrically it's below the horizon, optically it's above the horizon, astronomic refraction.
So the sun is apparent?
Apparent having to do with as it appears by refraction, and then there's apparent as the ephemeris, which deals with simultaneity of the astronomic bodies since they're all at different distances. So yeah, the word apparent has been misused in this form many times.
Real quick. So what is more important to you, Shoe Bill? The geometric position of a celestial body or the apparent position?
Equal footing. I can't use one without the other.
Wow.
Absolutely equal. If I make a measurement to as it appears, and then I use the ephemeris to get the GP, and then calculate the geometric vertical angle, and they differ by a predicted amount. And the predicted amount are the formulae that we were just talking about. And I have, by my measurements, I find coherence
Okay, so don't you find it a little coincidental that the geometric true position of a star being occluded by a mountain peak actually matches up with the plane trig that was calculated beforehand?
No, I am questioning the methodology of how he came to that determination.
Well, actually, if you guys jump back to that, I wanted to actually ask Shubil a question. If you guys did kind of, because I didn't want to interrupt like the other, some of the
Go ahead,
exchange.
bro.
Well, I just want to ask, like with that, like because with the timing of the star and all that stuff, because with the everything, like Shubil, do you think, like, I guess here, let's say it was this kind of a setup. You were blindfolded, taken somewhere, blindfold taken off, boom, you see a mountain, a star, you then take your time. Just from that, okay, and you can know the distance. Let's say you know the distance between your feet and the mountain, which is a big thing to give. But let's just say we know that, we'll just give you, let's say you know that distance for sure. Could you come up with a prediction for the globe, and then again, kind of like in that idea of blindfolded, meaning you haven't previously gone on Stellarium, or you haven't previously gone up to the peak of the mountain and taken anything like that. Just from the timing, could you predict with the globe math and information accurately what the angle actually is at the top of the mountain based on the globe? And do you think you could accurately predict it?
Well, I don't know about this whole blindfolded thing because I would still need to know my geographic position and the GP of the star. Yeah, it's like
no, that can all be given to you. Yeah, I just kind of was saying blindfolded. It doesn't matter. That doesn't matter. It doesn't. The blindfold was actually pointless because that doesn't matter.
In other
you
words,
would know where you are, all that stuff. That's fine. I'm just saying. My point is, you didn't already pre-calculate anything. You just did the timing and the observation. But yeah, you would need to know the star and some of these things.
Okay, here's another thing that I have done many times. I have set my instrument up, put the telescope at the predicted refracted angle to the star, to the sun in this case, and recorded the time that the star or the sun was centered on my crosshairs and compared that time to UTC time. And again, I find 1 or 2 seconds of time difference. So without refraction, I'd be off a significant amount. With refraction and the geometric, I can use the crossing of the sun to my crosshair to actually determine time. So now I can use time and measure the zenith angle from my location to the GP, not knowing my geographic position, and that's celestial navigation. And when I do that to 8 stars with 45 measurements in a single sitting, to stars that are over where the GP is over 5,000 miles away, and refraction is like 6 or 8 miles of refraction in the distance to GP, I end up with about 60 to 100 meters of error, which reflects about 1 or 2 or 3 arc seconds. So so the apparent position, the geometric position, the refractive position, you can't omit any of them. And I posted the refraction value, the formulae that I have used on that print. The top formula is a Smarts formula, and the highlighted formula is a coefficient for low elevation angles. And using that to a star, which I admit was what some, extreme 13 degrees above horizon, I'm getting errors about the width of my crosshair of my instrument. And whoever said a theodolite measuring stars is retarded, that is so naive. They are built for this. A sextant is a crude version. A sextant does the same thing, but it's just a much lower order. It's like the difference between using a tape measure and a micrometer. They're doing the same thing. So if a sextant can do it, a theodolite can do it better.
Okay. So at what point do you apply these formulas? At what 5 degrees from the horizon, or 10 degrees? When do you start applying these formulas that you're talking about?
Well, the upper formula, the Smarts formula, is used at all zenith angles. The coefficient, you can use that at all vertical angles. The point in this document is that when you get into the very lower angles, below 10 degrees, then you have to use the coefficient, but you can use it always. So I always use those two formulae, the SMARTS formula and the highlighted formula, which is going to be almost identical to any other formula you find for minor differences. And in these formulae, you can key in your measured pressure, your measured temperature. Nothing assumed.
I mean, if you've got the distance to the mountain and the height of the mountain, like those are assumed, you are kind of adding an assumption that your formula is correct.
No, this word assumed is really kind of offensive because you are discounting the fact that experience has verified and come to terms with the reality, as opposed to assumed I'm dealing with functioning successful product to clients.
Okay, offense is taken, mate, not given. So that's on you.
So in this case,
so in my case,
one of the things I have done.
I'm done, man. I was here for a good time and a short time, not a long time.
In my case, what I have done numerous times to radio towers 25, 28 miles away, where I know the elevation of the instrument and the radio tower, and I measure the vertical angle or the zenith angle, which is refracted, compare that to the predicted by the coefficient of refraction that I determined myself for location, and I end up again a handful of arc seconds different. Now, a handful of arc seconds is at the noise level of angle measurement, unless you put in a whole lot of effort.
You seem to exert a lot of pride, Bill, and I appreciate that, man. I got pride in certain things that I've done, and I don't like other people tearing it down, right? So you do realize that is actually going to, like, it means that if you're so pride and so proudful about this subject, you're never going to recede. Even if you're wrong, your pride will just overcome that will.
Come on.
Well, again, I've held a professional license for over 30 years. I have been doing this for over 35 years. So yeah, I have held my skepticism, I'd made my shortcuts, and I have found that the devil's in the details. And so
it is.
So when I produce product for client, I have held it financial liability of being wrong.
Yeah, Ricksky. So this goes back to the question I was asking people earlier today, because I've met one Globe Defender who says even if the government came out tomorrow and provided all the evidence saying, okay, we were lying, it is flat, like the people were trying to tell you, there's going to be a portion of society that won't believe it.
I mean, sure, of course. I mean, it's pretty funny. Everyone acknowledges the government lies. They're not willing to agree upon how much.
So true.
And I have proper equipment. And I have a lot of experience.
Well, it's just funny, man, because a guy came out of nowhere and came up with a more accurate means of measuring the sky than all of your gizmos and gadgets, which is kind of what I feel like's kind of going on in a lot of cases here. Is like, dude, man, I used to be a gadget guy too. I used to love my little gadgets and I buy little shit and I think it empowered me somehow to sort of do something.
No, in concept.
Stop cutting him
You're
off.
literally interrupting him.
You keep cutting him off before he gets to finish.
That's all right.
In concept, yes. I'm sorry.
Holy shit.
Just finish what you were saying, Rick. Or not Shubil.
I'm sorry.
So Shubil can go ahead. That's what I was talking.
You're done? Okay, go ahead, Shubil.
In concept, the Theodolite is perfectly fine without hesitation. It's the way he's applying it.
Is it a more accurate means of measuring the sky than your Theodolite?
No, it's very much equivalent to within the tolerance of a few arc seconds.
If it's equivalent, then what do you say about the angle matching up with pretty much 40 observations now? It's just a flat baseline, and it works. It's cool. Earth is flat, bro.
Yeah, the Earth is flat. You're right.
You're right. You're absolutely right. The shape of the Earth still up in the air.
Clip it.
No, it's on the ground, mate. Look down. You keep looking up. That's the problem.
That was good.
No, I only have one thing to say to Shoebill, then I'm going to go AFK again. But Shoebill, you're coming off very hostile with your tone of voice, and normally I do that once in a while as well. But you have to understand how people are going to respond to that. It's not very well received.
I was called a retard for using a theodolite against stars, which is a purpose-built instrument for measuring the angle of stars.
No, well,
Okay, let's not do tone police now. It's all right.
No, I'm just saying.
He sounds like he's using Jordan Peterson AI voice changer. That's what he sounds like to me.
Nothing. I know how to speak to people properly. Then a lot of other people do as well. But Shoebill seems to be coming off super fast and aggressive, like he's on meth or something. It's like,
all right, easy,
calm down a little bit, man.
Yeah, that's even worse.
Let's not do that, you guys. Let's not call each other names or say you're on
I'm
meth
just
or anything like
pointing
that.
out. Chill out. I'm just pointing out that he is
That's
a
not fair
little.
to him, dude.
I'm just pointing out that he is a little hyper aggressive when it comes to making his points. I'm not saying he's wrong. I get passionate, but like too much coffee or something. I don't know.
No, he's passionate. He's talking about the stuff he does, bro. He did it for 35 years. I get the passion, but you know.
Thank you, definitely. Leslie, now that you're here, no pressure. I don't want to put you on the spot, but just out of curiosity, let's say the government flipped tomorrow. Would you believe them?
Nope.
Leslie would be like, it's a freaking conspiracy.
They're lying now. They're actually lying now.
Thank you, Leslie. What about you, Rohit? Would you believe?
What if the choice was like between going with the guy, like you got Elon Musk as the space pioneer, and then I don't know. Let's try to think of someone else. Like maybe the Democrat. What if the Democrats came in and said it was flat, and then the Republicans are all like, "It's still a globe, man." Like
that'd be awesome.
What was the question, Aiden?
Oh yeah, hi, Ruha. Welcome back. So let's say the government, we wake up tomorrow, we're pouring our tea or coffee, and we turn on the TV, and it's breaking news: the Earth is flat. Government's doing a full
disclosure
release. Would you believe them?
Do they have evidence, or they're just saying it's flat?
Oh yeah, they're presenting the evidence as the day goes by. They got video evidence, etc. Everything. Would you believe them?
Yeah, they would need to. There would need to be an explanation for why it measures as a globe. Who wants to see a ship over the horizon? By the way,
because the sky.
Water doesn't stick to
kaleidoscope.
spinning balls. Are you crazy?
there you go. There's a picture in the chat I just took. To the very left, just to the left of the stadium arc, is a ship. That little white dot is the top of a ship.
Okay.
See if I can get a better photo. There you go. Is that better, that one? Second one? Yeah, just to the left of the stadia. And that ship is called Gasham Odyssey.
Why is the horizon so curved?
Yeah, I feel like you've actually presented this exact same photo before.
I've seen it, yeah.
No, it's just a
What was
photo.
your?
And I feel like I left at the exact same time.
For my auto level.
How about
Why
you
is your
post
auto
another
level
picture of
curved?
your balloons again, Ruhif? Just do it. Make me happy.
Do you reckon that auto level's like that just so that it can sort of seem to make the ground more curvy than it actually is, and it just
No,
makes
it's
people
got
feel
barrel
satisfied?
distortion. It's got barrel distortion. Don't worry about the curve of the horizon. Look at the little tiny white dot. That's the top of that ship.
Does it need to have barrel distortion, or is that just like an optional extra you can add in?
It's just a circular lens. It has barrel distortion. If you're looking through the center,
It's called an artifact of optics. It's an artifact of optics.
there you go. Increase the level. There you go.
Dude, you think that picture proves anything? That's not.
Where's the rest of the fucking boat? Where's the rest of the boat?
Oh my god, dude.
You've got better, like the top of the ship, right? The top of the ship, right? You've got slightly better angular observation, right? Do you agree?
If you can model the bullshit you're about to say, please do it. I don't want to hear bullshit.
Do you want to engage in the topic of the conversation, or do you just want to hear bullshit like up front? I am asking model the questions. I'm going to lay it.
Right. If you want to go with Rayleigh criteria on bullshit, please model it rather than talk about it. Pretty please.
It's not what I'm
I don't
talking
even know what he's going to say yet, bro. Come on.
Whatever it is,
listening.
is modeled.
If I'm about to kick you just later, because I don't like your religion, you really don't have to wait to speak. Well, you're just going to get kicked out of every channel on Discord by the time you're.
All right, Rick. All right, Ruhif, take. All right, Taylor wants to go back and forth with Ruhif. I think she's going to ask him some questions for a while. Go ahead, Taylor.
Okay, well, I was just going to ask about the barrel distortion, in particular, because when I was looking through the Theodolite at something, that wasn't curving with other cameras, it looked heavily curved and distorted. And if you were to even just take a picture, right, I had like 3 different cameras I tried, and then I looked through my Theodolite, took a picture of the eyepiece, and then if you even look and compare those side by side, and then basically like count, like for example, if you're looking at a bridge, you count the number of pillars, and then you can measure number of pixels to see how much it's actually curving for one camera versus looking through the Theodolite, and you could see that it was like the distortion was more exaggerated with the Theodolite than it would be like in reality. Even if
looking
you
through
were to
the
take into
center.
account the magnification. That's why I said like particularly counting a specific location and then measuring the pixels ratio for each. So like, what's going on there? Do you know about like barrel distortion and like how that works?
Yeah, there's barrel distortion, right? So there's radial from the center to the edge. That's the distortion, right? So what I've tried to do with that ship, the photo of the ship, is it's pretty close to the center line, all right? So there's not a huge amount of distortion. I'm not claiming that these pictures are evidence of left to right curvature. I'm pointing out that the very top couple of meters of the ship is the only bit that's visible. As Shubil put a photo a couple of minutes ago with the levels cranked up.
Oh, I didn't even
And then
see
I
that
put a photo.
ship. I was just looking at the curvature of the horizon.
All right, yeah. So yeah, Shubil up the levels, and you can see the little white dot to the left of the stadia. And then I've posted at 11 minutes past a picture of the actual ship that I'm seeing.
Yeah, so you can actually see things like that are coming over the horizon, including like sunrise and sunset, how there's a lot of distortion near the horizon. I don't think these types of pictures are really credence or evidence of anything, one way or another. So,
Okay, where's the bottom 90% of the boat?
right. So that's a good question. Where's the ground whenever boats are floating over top of the horizon? You know,
Yeah,
where
that's
is the
not a
ground?
refractive effect. That's the reflection.
It's not refraction when boats are floating over the horizon.
It's worth
Correct.
noting.
So the
It's
boat
worth noting.
over the horizon.
It's worth noting that the water line on the ship is sea level, and when it's near and far, the ship did not change elevation.
It doesn't matter. What I'm saying is we can see boats do all kind of crazy things, including float in midair.
Yeah,
What
that's
the
not
boats are
refraction.
doing is not
That's
really good
just
evidence one way or another.
that is just the clouds reflecting off the water, so it appears roughly the same color as the sky.
We can also see things being mirrored and towered and loomed on the horizon.
You mean this example?
This is not, you're giving a particular type of refraction and acting like it's some type of evidence, even though we commonly see other types.
Yeah, so Shubil just posted the floating boats. It's
It's
not a refraction
That's
effect.
not
It's just
refraction.
reflection.
That's not a Theta Mirage that doesn't exist anymore.
No, that
Theta
they
Mirage is that
exist.
real?
This is not that.
Oh, this is not that. How would you prove that?
That's a
How
portion
do
of
you know?
glassy water. That's a portion of glassy water next to choppy water, and the horizon is nearly indiscernible from the blue sky and the reflection of the blue sky off the water. And you can see.
So how would we be able to tell the difference of this, mirroring, as you say, or this glassy effect of water versus
upside down images.
I wasn't
Better
finished.
optics.
I wasn't finished either. How would you tell the difference between that and a Theta Mirage?
Right, Fata Morganas are multiple images upside down, right side up. This is not that.
Okay.
This is not a mirage.
According to the Morganas that I've looked at, it just says that they're floating in midair, which is kind of what we see with a boat.
Yeah, people can be wrong.
What's your definition of the Theta Morgana then? Maybe that's important.
Yeah, multiple mirage images. They're
It has
very,
to
very
in
complicated.
your case.
Okay.
Yo, the
Second.
glassy water you guys mentioned. You know where else we see glassy water? You know that illusion on hot days where you're driving down the road and it looks like there's water. That actually happens when there's
That's an inferior mirage.
indentations. When there's indentations or dips in the road, there's specific angles where light hits the inside concave parabolic surface and reflects back at a specific angle to the observer, which creates that mirroring effect. Just FYI.
Okay, thanks, bro.
How do you know it's the concave portion of? How'd you know it's the concave portion and not the peaks?
Observe it, see for yourself.
No, that's not. Nope.
That's my answer. So my answer is
why would you see the bottom inside of something if there's a peak that towers over it?
We've got another boat coming, people.
Well, I just wanted to substantiate this claim.
Google it. Next time you're driving on a hot day, pay attention to where it looks like it's mirroring on the water. It looks like it's fake water, and watch as you get closer to it. You'll see a dip or indentation on the road.
Okay, so you're saying it's the inside of those smaller portions, but not the peaks creating a surface over distance.
I never said the word peak, man. I don't know where you're going with that.
Well, you're saying we can see the inside. Look, if you're saying it's the concave inner portion, like of something, clearly there's something peeking over it around the rim or somewhere external to that.
Look at the image I posted. That's basically the idea. Skip the sun. It's not about the sun.
So Fata Morgana is no longer just a boat floating over water? That doesn't exist anymore?
Well, I mean,
No.
the Globers can't say it's just a boat floating over the water. I mean, we could clearly see there's more water. If you turn up the contrast, you could see a new horizon line is formed. You could see details of the surface of that water. It's not just the boat is shifted up. It's we're seeing more.
Okay, I think that the picture that I posted is a true Fata Morgana. It's what looks like two mediums in air.
No, I'll post it.
If
I
you
mean,
want
anybody
to
can just look up Fata Morgana and look at the pictures that come up. It's obviously when boats float over water. That's an example, but they're trying to say that's not actually
No.
much.
People on the internet can be wrong, Taylor. That's not a Fata Morgana. Anyway, I
Okay,
posted
so
another.
you tell me your definition of it then.
Yeah, multiple inverted images. So it's
It has to be multiple inverted images, according to what definition?
I'll defer to Andrew Thomas Young.
Okay, pull up his definition.
I'm not in a position to pull up a definition.
And an example. You should be,
Can you
because
see
that's
the ship
wrong.
that I
It doesn't
posted?
have to be multiple inverted images.
All right, I posted another ship anyway. And
I
that ship is.
posted one ship total.
Hang on. That
Tell
ship
me
is
what you think is
called.
happening there in that picture I just posted.
Hang on. That ship is called the Spa Libra. Let me just post a
What
photo.
do you think's happening there?
Hang on. Posting a photo of the ship.
Did you look at mine?
Not yet. I'm just going to post a photo of the ship, and then I'll have a look. Oops, where's Discord? There we go.
Hey Taylor, do you remember this from Andrew Thomas Young that Napalm posted? What's the difference between standard atmospheric refraction and sinking refraction?
What was the answer? I can't remember what he said.
Almost nothing,
Nothing.
Insane.
except a very high lapse rate.
Nope,
And
there's
a
literally
curved Earth.
nothing different. Nope.
Now, all his refraction models depend on the curvature of the refractive medium. You apply it to a flat
Just
Earth.
tell me what kind of refraction that was right there. What was
Upwards and
happening?
downwards have to do with the conditions at the moment. That's why the Black Swan has multiple images that look grossly different from the same location. It's not that the Earth changed, it's the conditions changed.
I'm gonna keep asking y'all, what's happening in this picture I just posted? Shubil,
Yeah,
Ruhil?
the sky is being reflected off the water.
Oh, the
Looks the same
sky's being
color.
reflected off water.
These
That
floating
photo,
boats.
yeah, that photo is kind of low
You know what I'm
integrity.
saying? So the horizon is actually much higher, is what you're saying?
The horizon will be roughly where the boat is. If you change the levels of the photo, you might be able to see the horizon a bit clearer.
Mm. So wait, how do things get refracted up to appear taller then?
Appear to even stretched or just appear higher than its geometric position?
It would be extreme refractive conditions, extreme light bending down, which makes it extremely appear higher than it is.
So wait, what would be something that's refracted to be taller? Ruhif?
Most things are. Most things are because the
Oh,
typical
most
density
things are.
gradient.
So what's happening here? That's not one of them?
Which one?
The boat
The
that I
floating
posted.
boat?
Yeah.
The floating boat, for the fifth time, has nothing to do with refraction. For the fifth time, okay?
And
prove it.
but further, the photographs of this caliber in this environment are not how you measure the shape of the Earth.
It doesn't matter. I'm just giving you the notion that boats can be refracted in multiple ways. Either the horizon can be refracted down or up or whatever it may be. That happens all the time. If you look at time lapses of any water or bay or whatever it may be, that will happen. That things can appear shorter, but for some reason, in this case, you guys want to acknowledge that things can appear higher. So whenever you say, oh, well, what's happening with the bottom of the boat? And I say, okay, well, what's happening here when the boat's floating? You want to say that's not refraction?
There's not two mediums. It's
Oh,
something else. There's not two mediums. It's something else.
What is it exactly that
Does
that
light
we're
change direction in a sugar water tank?
what is it exactly that we're contending against the Globers? What is it that we're not liking?
Taylor keeps wanting to put words in my mouth to say that's a Fata Morgana, and it's just not. So,
no, it's not. I'm saying prove that it's not. I've never said that you said it was. Just prove it's not.
proof. Do you want to get into a conversation about proof?
Yeah, go ahead. I'm saying everything I've learned about Fata Morganas would be something floating in midair. You're saying that's not a Fata Morgana. So I can show you sources that say that is.
Okay, but logically, how do I go about proving an explanation? What is the process?
You said your Thomas Young thing said that Fata Morganas have to be multiple mirrored images or multiple layers of images. And I'm just asking the source.
Oh, Google it. Google it on fucking Wikipedia.
You're going to reference it. Yeah, when I look at Fata Morgana, these are the examples it gives me. So you're saying that's not actually an example, though?
Would you like me to fill it for you?
I would like for you to
Fata
send me
Morgana.
sources to reference.
Fata Morgana Wikipedia Mirage. Fata Morgana is a complex form of superior mirage, visible in a narrow band right above the horizon. Blah, 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 blah. Fata Morgana's mirages significantly distort the orbit of objects. The mirage comprises several inverted and upright images stacked on top of one another. Is that good enough?
I want to hear the whole definition, but yeah, I just want to see it. I want to see an official definition showing that this would be one. Everything I've read on physics forums about refraction says that this would be one, and that's usually the example.
Here's a clue. Go to Wikipedia, type in Fata Morgana, and read.
I think we should read Wikipedia.
Post the link you just read. Let her read.
Yeah, that's fine.
Hang on.
So can a boat ever appear higher because of refraction? Can a boat ever appear higher because of refraction?
Yeah, that's typical. They typically appear higher than their geometric position because of refraction, yes.
But
That is not a floating boat.
What about when they appear lower? Is that Earth curve?
When they appear lower,
Yeah, like the looming or sinking
generally,
effects.
that's sinking, yeah. That's less
That's
common.
Earth curve,
and then-
though.
No,
So
that's
that
less
whenever
common.
that happens, it's Earth curve.
That's